Hi dear students. So today we are going to discuss the fourth subrule under category 1. I have told you there are two main rules, 1 and 2. In that we have discussed 1A, 1B, 1C, and now we are going to discuss 1D. Okay, so let's see what this rule says actually. So the rule says if more than one multiple bonds are present, then select the one which contains a maximum number of multiple bonds. What does that mean actually? It is telling that whenever you are choosing the principal parent carbon chain, and if you find that in the given compound if there are more than one multiple bonds are there, then what you need to do? You should choose a path that contains the maximum number of double bonds. Okay, so listen here. So in this example, okay, you can see here, if I try to find the longest path, 1, 2, 3, 4, 5, 6, I can see 6 carbons are there if I go in that path. Suppose if I go like this, 1, 2, 3, 4, 5, but 5 carbons are only there. So students usually used to make a mistake here. They will try to choose the path which contains the maximum number of carbon atoms. That is wrong here. That is what this rule is saying. This rule is saying try to choose the path which contains the maximum number of double bonds. So maximum number of double bonds means if I go in this path, how many double bonds will be there? Only one will be there, correct? But if I go in this path, like this, if I go in, then what will happen? 1, 2 double bonds are there. So my principal chain should be which one? This one should be my principal carbon chain. Please understand, here we have only 5 carbon atoms, and here in this path there are 6 carbon atoms, but still we are choosing this path. The reason for that is, what is actually, we have told that if the try to choose the path which contains the maximum number of double bonds. Okay, but here one more thing you need to remember, always you should not do like this. Here it does not have any functional group. We know that the priority is like first functional group, then multiple bonds, then comes number of carbon atoms, then comes the substituents, correct? So here no functional group is there, then the second priority goes to what? The number of multiple bonds. So that means if there is no functional group in the compound, then you should choose the path in such a way that it should contain the maximum number of double bonds or triple bonds. Generally I am speaking multiple bonds. Okay, so I hope you understood this example. Now we will try to see how to numbering. So right now we have done like how to choose the parent carbon chain. Next we need to know how to number this parent carbon chain, in what priority, in what order we need to number it. Then we will go to the format of IUPAC name. Okay, hi students, so let's see the main rule 2. So main rule 2 speaks about what? Numbering in the selected parent carbon chain. So you have, in the first rule you have selected the parent carbon chain using some sub rules. So in the next step you are, what you are going to do? You are going for the numbering actually. Numbering of this selected parent carbon chain. Now the first sub rule under main rule 2, that's why 2A is coming. Okay, 2A, that means 2 is the main rule, under that the first sub rule A. Okay, so what is the first sub rule stating? Just we will go through that. The selected parent carbon chain is numbered from that side from which the functional group or multiple bond or substituent should get the lowest number. That means once you have selected the parent carbon chain, you should start the numbering in such a way that from which end you should start numbering. You should start the numbering, you should choose the side in such a way that the functional group or multiple bond or substituent should get the lowest number. So here students will get doubt, sir, if all the 3 are present, what we should do, sir? Which should be given the lowest number? That's why the next line states that the priority order, who should be given the first priority? Functional group, then multiple bond, then substituent. Now let's see one example so that you will understand it very easily. Okay, now you have the first example, CH3, CHOH, CH2, CH3. So first step is selecting the parent carbon chain, and you know that here the functional group present here does not have a carbon. So what is the rule? So OH group should be connected to some carbon, that carbon should be part of the parent chain. That is the only rule. So we know that how to choose the longest path, 1, 2, 3, 4, 1, 2, 3, 4. There is only one possibility. So let me say this is my parent carbon chain. Okay, Now the next step is the numbering. So I can start the numbering either from the left to right or from the right to left. So here, if I do it from left to right, what will happen? 1, 2, 3, 4. So the number that is coming to OH group is here 2 is coming. Okay. Now if I am going to do it from the right to left, 1, 2, that is in this direction. Okay. 1, 2, 3. So 3 is the number that is coming to the carbon atom which is connected to the functional group. But the rule says that the functional group is attached to some carbon atom that should get the lowest possible number. Okay. So what should be the correct numbering? 1, 2, 3, 4. Why? Because if you go in this direction, the number that is coming to the carbon atom which is connected to the OH group is 2. But in the other way, it is 3 actually. Okay. So I hope you understood. Next we will go to the second example. So here it is very easy to choose the parent carbon chain as there is no branches or anything. So this is my parent carbon chain. Okay. Now the doubt comes here, sir, whether I need to go from left to right or right to left. So if I start from here, 1, 2, 3, 4, what is the number that is coming to the double bonded carbon? So whenever there is double bonded carbon, it will be between two carbon atoms. So try to choose the number that is lowest. So in this case here 3 is coming, correct? 1, 2, 3, 4. So 3 is coming. But if I go it in the other way, 1, 2, 3, 4, that means 1 is coming here. So then 2. So minimum number is 1. So which should be the correct way from the right to left? Why? Because they are saying that there is no functional group, then who should get the priority? The multiple bond should get the priority while numbering. So it should get the lowest possible number. So this should be my numbering. Understood? So next example, please try it yourself. Okay, so here how to choose the longest path? Again it is the same. So I have parent carbon chain means 1, 2, 3, 4, 4. There is no other deviations. So this should be my parent carbon chain, longest possible parent carbon chain. Now once this is chosen, we need to number it. Now think like if I number in this way from here to left to right in this direction, 1, 2, 3, 4, 5. What will happen? You can see that 1 is coming here. Okay. Let me say. So here I will put it in this way itself. 1, 2, 3, 4, 5. I know that here functional group is present, multiple bond is present, and substituent is also present. So what is the number that is coming for the functional group? If I go from in this direction, so it will be 1, 2, 3. 3 is the number that is coming. Okay. But if I go in the other direction, 1, 2, 3, then also 3 is what is coming. So that means it is irrelevant when you go from left to right or right to left. Functional group always have the number 3. Now next we will look for the multiple bond. So if I go in this direction, 1, 2, 3, 4, 5. So the minimum number coming here is 4 actually. But if I go in the other direction, 1, 2, 3, 4, 5. In that case 1 is the number coming. So that means which should be the correct way of numbering? From here to here. Because after the functional group, who should get the priority? Multiple bond. Why we are doing that? Because in this case the functional group in any direction, if you number it, it is getting the number 3. So next priority we should give to multiple bond and check in which direction for multiple bond it will get the lowest possible number. So my way of numbering should be 1, okay, 1, 2, 3, 4, 5. So I hope you understood this rule very clearly. We will go to the next sub rule. Okay, so next we will go to the next sub rule, that is 2b. Okay, so what is 2b stating actually? So this states that if a carbon containing functional group is present, so it is now specifying more. We know that functional groups are of two types. One is a functional group which does not contain carbon, and other is a functional group which contains carbon. So it states that if the carbon containing functional group is present, then give the lowest possible number. Lowest possible number is what? 1. Correct. So try to give the lowest possible number number to the carbon of that functional group. So here there are two cases. So most of the time when a carbon containing functional group is present, we know that we will try to choose the parent chain in such a way that we will start from that particular functional group. But there can be a special case where carbonyl group, it is a carbon containing functional group, but always this carbonyl group lies between two other carbon atoms. So we cannot start or choose the parent carbon chain from this carbonyl group. We should choose either from the left or from the right. Okay, so listen here. So we have, first we see this example. So here you have in this compound a carbon containing functional group is present and double bond is present. So how to choose the parent carbon chain? We know that even though 1, 2, 3, 4, 5, 6 carbon chains are present, first the priority goes to whom? Carbon containing functional group. So I will choose the parent carbon chain from this position. Okay, then I will go in such a way that try to include the maximum number of double bonds. So I can do that only in this direction. So I have chosen, and this is my parent carbon chain. Understood? So first priority goes to carbon containing functional group, next priority goes to including the maximum number of double bonds. Okay, if these two are not there, then we can choose the one which contains the maximum number of carbon atoms. Then the priority goes to the substituents, correct? So here next question is how to number it. We know that if a carbon containing functional group is present, try to give the lowest possible number to that. So that means this should be 1, this should be 1, and this should be 2, and this should be 3, and this should be 4. Clear? Okay, so next we will go to second example. So in the second example we have a carbonyl group is there. So how to choose the parent carbon chain? I know that this carbonyl group always lies between two carbon atoms. So I should include this carbonyl group in my parent functional group. So this should be my parent carbon chain. Now I should try to number it in such a way that this carbonyl group should get the lowest possible number. So lowest possible number, if I go in this direction, 1, 2, 3 will come into picture. Okay, if I go in this direction, 1, 2 will come into picture. So that is my correct numbering, because 2 is the lowest number. Understood? So this is the basic way you need to number it. Now we will try to see all these rules, and at the end of the day we will see different examples, and I will help you how to apply these rules. Okay. Next we are going to see the third sub rule under the main category 2. Okay, so when you go into the third sub rule, it itself is divided into two parts. Okay, we will say the first part as 1 and the second part we will discuss. Okay, so first statement of this third sub rule is this rule, whatever we are going to discuss here, is applicable only for symmetrical conditions. So I will explain what is symmetrical conditions. Let's see that. Okay. Now what is the first rule saying? The rule states that when two or more substituents are present at symmetrical position, very important, at symmetrical position, then follow alphabetical order for numbering. So what does that mean? So let's see first of all the example 1 where what is symmetry actually. So you have a compound here. Now what is symmetrical means, if I am going to divide this compound into two halves. Okay, so it should be almost the same with respect to the positions. For example, now if I am choosing my parent carbon chain like this. Okay, please listen, then only you will understand. Okay, so this is my parent carbon chain. Now I am going to number it in one direction. So let's say in this direction. So 1, 2, 3, 4, 5. Now tell me what are the substituents numbering that is coming here. For chlorine, we know that there is no functional group or multiple bond is present here. So for chlorine, what is the number coming? We know that for chlorine it is 2, and for bromine it is what? 4. So this is the numbers we are getting in this direction if we go from left to right in my case. Okay, now suppose some students have not done like this, the other way they are doing, and they are telling me, sir, I am going in this direction. So 1, 2, 3, 4, 5. So here what is the case? Here I understood that for bromine you are getting the number 2, and for chlorine you are getting the number 4. So they are telling that, sir, both are substituents, right? Sir, then why you prefer one, the first way, left to right, or why you are preferring right to left? What should be done here? Because here 2 and 4 is coming, here also 2 and 4 is coming. Only difference is the substituents are getting interchanged. So this is the case of symmetrical condition what I am talking about. Now we should know who should be given priority, chlorine or bromine. In that condition they are saying you should give position or you should give priority in such a way that you should be considering alphabetical order. Whoever comes first in the alphabet, he should get the lowest possible number. So here tell me chlorine or bromine will come first with the alphabets. So we will take the first letter, it is C, here it is B. We know that B comes first, then only C. So bromine should get the high priority. Bromine is getting high priority means what actually? It should get the lowest possible number. So what should be the correct numbering? This should be the correct numbering. That is 1. So this is wrong. 1, 2, 3, 4, 5. Understood? So this is the symmetry I am talking about. Now we will go to the example 2. Here also you will understand. Then it becomes easy for you. So here also let me try to choose the parent carbon chain. 1, there is no functional group, there is no multiple bond or nothing. So if you go 1, 2, 3, 4, 5. This is C2H5. So CH2, CH3. So 5 I will get. 1, 2, 3, 4, 5, 6 I will get. 1, 2, 3, 4, 5, 6, 7 I will get. So which should be the longest continuous parent carbon chain? This should be my longest continuous parent carbon chain. Correct? So the next process is numbering. So here also I am feeling some symmetry. Why? Because if I go in this direction, let me say 1, 2, 3, 4, 5, 6, 7. So you can see here for ethyl group, ethyl is a substituent. So that is getting the number 3. And for methyl, you are getting what actually? The substituent number as 5. Correct? Now suppose some students, they start from the other direction to this direction. Then what should be the numbering there? You can see here. So it will be done like this. 1, 2, 3, 4, 5, 6, 7. So in this case, methyl is getting the number 3 and ethyl is getting the number 5. Ethyl is getting the number 5. Correct? I hope you could see. Now here also you can say symmetrical condition 3, 5, here also 3, 5. Only the substituents are getting interchanged. So what should be our way to proceed? We need to check ethyl and methyl. Who comes first? E and M. Who has the lower? Who comes first in the alphabetical order? E comes first in the alphabetical order. So E gets the priority. That means ethyl should get the lowest possible number. That means this is wrong. We should do it in the initial way. That is, you can listen. You can see here. Okay, 1, 2, 3, 4, 5, 6, 7. So this is correct. So this is wrong. This I can rub it. Okay. So I hope you understood the condition of symmetry. Now we will go to the part 2 of this case. There, instead of 2 or more substituents, we will speak about multiple bonds. 2 or more multiple bonds are at symmetrical position. In that case, what we will do? Okay. So we will go to the second part of the rule actually. You can see here second part. So what is the rule stating? The rule stating that this is also applicable for symmetrical condition. Okay. It states that when double bond and one triple bond are present at symmetrical position, then the priority should be given to double bond. So that means if they are at symmetrical position, then only you should be giving the priority to what? Double bond. Let's see here. So the example you can see here. So I know this is my parent carbon chain since there is no branches or anything is there. Okay, correct? So if I am trying to number it, so I am numbering in this direction, think like that, 1, 2, 3, 4, 5. So you can see here for double bond the minimum number coming here is 1, and for triple bond the minimum number coming here is 4 actually. So some students, they will do it in this way. Okay, 1, 2, 3, 4, 5. Now they will say that, sir, for triple bond the number coming here is 1 and for double bond the number coming here is 4. So you can see again a symmetrical condition just interchanged. They say that in that case, if there is a conflict, if there is a symmetrical condition is there, you can see symmetrical condition is there, then the priority should be given to whom? Double bond. That means this is wrong, because here triple bond is getting the priority and getting the lowest possible number. So that is wrong, and I will switch back to my initial numbering, that is 1, 2, 3, 4, 5. So this is a one-time question in NEET also. So please remember, if there is a symmetrical condition, the priority should be given to double bond. Let's see the example 2. So on looking at the example 2, I will select the parent carbon chain. Okay, I have chosen the parent carbon chain. Now I am trying to number it. Okay, so somebody has numbered like this: 1, 2, 3, 4, 5, 6. So for double bond, here the number coming here is, lowest number coming here is 2, and for triple bond the lowest number coming here is what? Actually 5. Now some person, instead of doing like this, they have done it in the opposite way. Okay, that means what? Actually from here 1, 2, 3, 4, 5, 6. So in that way, for triple bond they are getting the number as 1, and for double bond they are getting the number as 4. So I can say this is not a case of symmetrical condition, because in symmetrical condition same numbers should come in both directions. So this is not symmetry. So here you should not apply this rule. You should not give priority to double bond. In that case, what you will do? You should choose the path in such a way that any of the multiple bonds should get the lowest number. So here the lowest number is which one? 1 is the lowest number. So that number 1 is coming in which way? It is coming when you are numbering from right to left. So this should be my correct numbering. So that's why I am telling this is wrong then. Okay, so that's why I am telling, if it is symmetrical condition, then only you give priority to double bond. If it is not symmetrical condition, it is not like you should give priority to triple bond. It is not like that. You should try to put the maximum way of numbering and try to see in which path, which multiple bond is getting the lowest number. Sometimes there will be double bond will be getting the lowest number. In that case, that will be correct. Understood? So whenever there is no symmetry, you should number it in both possible ways and check in which direction the double bond is getting the lowest possible number, and that is my correct way of numbering. Okay, I hope you understood. This rule is very important. So we will go to the second part of the rule. Actually, you can see here second part. So what is the rule stating? The rule stating that this is also applicable for symmetrical condition. Okay, it states that when double bond and one triple bond are present at symmetrical position, then the priority should be given to double bond. So that means if they are at symmetrical position, then only you should be giving the priority to what? Double bond. Let's see here. So the example you can see here. So I know this is my parent carbon chain, since there is no branches or anything is there. Okay, correct? So if I am trying to number it, so I am numbering in this direction, think like that, 1, 2, 3, 4, 5. So you can see here for double bond the minimum number coming here is 1, and for triple bond the minimum number coming here is 4 actually. So some students, they will do it in this way. Okay, 1, 2, 3, 4, 5. Now they will say that, sir, for triple bond the number coming here is 1 and for double bond the number coming here is 4. So you can see again a symmetrical condition just interchanged. They say that in that case, if there is a conflict, if there is a symmetrical condition is there, you can see symmetrical condition is there, then the priority should be given to whom? Double bond. That means this is wrong, because here triple bond is getting the priority and getting the lowest possible number. So that is wrong, and I will switch back to my initial numbering, that is 1, 2, 3, 4, 5. So this is a one-time question in NEET also. So please remember, if there is a symmetrical condition, the priority should be given to double bond. Let's see the example 2. So on looking at the example 2, I will select the parent carbon chain. Okay, I have chosen the parent carbon chain. Now I am trying to number it. Okay, so somebody has numbered like this: 1, 2, 3, 4, 5, 6. So for double bond here, the number coming here is, lowest number coming here is 2, and for triple bond the lowest number coming here is what, actually 5. Now some person, instead of doing like this, they have done it in the opposite way. Okay, that means what, actually from here 1 2 3 4 5 6. So in that way, for triple bond they are getting the number as 1, and for double bond they are getting the number as 4. So I can say this is not a case of symmetrical condition, because in symmetrical condition same numbers should come in both directions. So this is not symmetry. So here you should not apply this rule. You should not give priority to double bond. In that case, what you will do, you should choose the path in such a way that any of the multiple bonds should get the lowest number. So here the lowest number is which one? 1 is the lowest number. So that number 1 is coming in which way? It is coming when you are numbering from right to left. So this should be my correct numbering. So that's why I am telling this is wrong then. Okay, so that's why I am telling, if it is symmetrical condition, then only you give priority to double bond. If it is not symmetrical condition, it is not like you should give priority to triple bond. It is not like that. You should try to put the maximum way of numbering and try to see in which path, which multiple bond is getting the lowest number. Sometimes there will be double bond will be getting the lowest number. In that case, that will be correct. Understood? So whenever there is no symmetry, you should number it in both possible ways and check in which direction the double bond is getting the lowest possible number, and that is my correct way of numbering. Okay, I hope you understood. This rule is very important. Hi, so let's see the fourth sub rule. Okay, so what is the fourth sub rule under category 2 is stating? If 2 or more than 2 substituents, if 2 or more than 2 substituents are present at unsymmetrical position. So earlier we were completely speaking about symmetrical position. Now this is applicable only at unsymmetrical position. They are present at unsymmetrical position, then follow the lowest number rule. Okay, what is lowest number rule? The other name of the lowest number rule is called lock-and rule. Very, very important rule. Okay, so let's see what is this lowest number rule. So you have the first example here. So you know that 1 2 3 4 5 1 2 3 4 5 6. So this is my parent carbon chain. There is no double bond, functional group, nothing is there. So I don't want to worry. I need to choose the longest continuous parent carbon chain. Okay, so now tell me, how will you number it? The question comes here is, if I go in this direction, okay, I will do it and I will write the locand 1 2 3 4 5 6. Now I will help you how to write the locand. The locand here means substituent, what is the number it is getting here, or for multiple bonds what is the number getting, or for functional group what is the number getting. That is called a locand. Okay, so here bromine, what is the locand that is getting? So you should always write it in increasing the number. So first number is 3, then CH3 substituent, what is the locand? 4. Okay, chlorine substituent, what is the locand? 5. So this is the locand you are getting when you go from left to right. Now some students will not follow this, they will do it in the other way. Okay, we will try the other way. So other method is, I can go from here to here. So 1 2 3 4 5 6. Now tell me, what is the new locand you are obtaining? So I should write it in the increasing order, that is 2, then 3, then 4. So 2 3 4 is the new locand I am getting. Is there any other possibility of getting the locand? Only these two ways are only there. Now I should choose which locand, that is the question here. Okay, now what the lowest number rule stating is, once you have written the possible number of locands, you should compare from the leftmost position, or it is also called first point rule. So first number here is what? Here it is 3 and here it is 2. So from this itself I will understand that lowest number is which one? 2. So then I will not compare the other things. Very important. Then we will stop at this position itself, because this is also called first point of difference rule. So here 3 and 2, which is the lowest number? 2. So this should be my correct locand. So that means this is my correct way of numbering. Understood? I will try to give you some examples of locands and you should tell me which locand is correct. Okay. Okay, think like this is another example. You are getting this locant. Now you are comparing the first two numbers. Okay, both are same. That means you should not conclude from the first numbers. Then go to the second number. Here it is 1 and here it is 2. So the lowest number is 1. Then don't go and compare the other numbers. You can stop here. So this is my correct locant. I will give you another example. Okay. So you have numbers like 1 2 9. Okay, so here you have examples like 1 1 3. Now tell me which is the correct locant here. Now on comparing first one, I understood both are same, you cannot conclude, so I will go to the next one. On comparing next one, I understood this is 2 and this is 1. Okay, that is lowest number is 1 here. Okay, so this is my locant. Some students will fail and they will go to the third one. They will say, sir, 3. So please stop at the point where you see the first difference. That is very important. Okay, I hope you understood. We will try to see next example. Okay, in example 2, tell me which is the longest path. 1 2 3 4 5 6. This is ethyl group. 1 2 3 4 5 6 7. So I will choose this as my longest path. Correct. So the next case is putting the locants. So I will try to put the numbering in all possible ways. So 1 2 3 4 5 6 7. So tell me what is the locant I am getting. So locant I am getting here is 3. Correct. Then 4. Then 6 I am getting. Okay. Now I will do it in the other way. What is the other possible method? Okay. Other way of numbering. So let's see. 1 2 3 4 5 6 7. Now try to write the locant. So you will get 2. Okay. Then 4. Correct. Then 5. Okay. So here on comparing, you will understand that in the first number itself there is a difference, which is the lowest number 2. So this is my correct locant and this is wrong. So this is my correct way of numbering. So this is the way you need to follow whenever there is unsymmetrical condition. If there is symmetrical condition, you will get the locant says actually how you will get here. For example, the locant says 2 4, and in the next case also you will get the locant says 2 4. This is called symmetrical condition. So in symmetrical condition, we already discussed what you need to follow. Actually when you follow locant rule, it is not able to solve your issue in symmetrical condition. That is the reason why the special rules are being made. Okay, so I hope you understood what is locant rule and this rule thoroughly. If you have any doubt, get back to us. So we will go to the last sub rule under category 2. Okay, now we are coming to the last sub rule, that is E part. So this is it. With that, all rules are completed and there are some miscellaneous rules. I will discuss that with examples. Okay, now what is this rule stating? The rule stating that there is a possibility like if more than one functional groups are present. Okay, if there are more than one functional group is present, then consider the senior most. This is a doubtful statement. I will explain. Consider the senior most as the main functional group and the remaining they are considered as the substituent. So here a doubt, I will explain the scenario. You have a compound where more than one functional groups are present. Then you will get a doubt, sir, in that case which functional group or from where I should start numbering. Then they are telling that if more than one functional groups are present, it is like there will be out of that functional groups, one will behave like the actual functional group. Even though others are functional group, we will call them as substituent. Then question comes, sir, then who is that particular functional group? They are telling, then consider the senior most. That means we have a table is there. A priority table is there. There we will list all the functional groups in the decreasing order of priority from up to down. And whoever lies top in that priority table, he is considered as the senior most. For example, now if you see this example, CH3, CHOH, CH, CHO, COOH. Now if you see here, there is COOH which is a functional group, CHO which is a functional group, and OH is a functional group. Now you will have a doubt, sir, how we will choose this. In this case, I may say, if you go into the priority table, you can see that who will come first? COH will come first in the priority table, then down the order CHO will be there, then OH will be there. The general way we used to remember here is always carbon containing functional group comes first in the priority table. Then only non-carbon functional groups will be there. I will give you that table, okay? Based on that you can remember first COOH, that there is an order is there. So based on that we need to decide. So from this I will understand that who is coming first, COOH. So I will take this as my functional group. Then what the rule is saying, if that is the functional group, then the other functional group should be what? How we should consider? They are telling it should be considered as substituent. Very, very important. So here I will mark this as my FG functional group, okay? And this both are what actually? Substituents. Substituent. Understood? So if both of these are substituent, just consider as substituent as any other thing. So my parent carbon chain, you know that if it's a carbon containing functional group is there, I should start selecting the parent carbon chain from that carbon, and this is my parent carbon chain. And many of them will ask here, sir, why don't you include CHO even though it is a functional group? Please understand, when COH is there, CHO is just a substituent. So this is the longest chain, 1, 2, 3, 4. Okay. Now how I should number it? 1, 2, 3, 4. There is no doubt, because carbon containing functional group should get the lowest possible number. So this is the last rule in the naming. Next we will try to see the format of IUPAC name. That means that format you should remember. Then based on that it is easy for you to name it. Okay. Hi. So next we are going to discuss the format for IUPAC name. Very, very important. You should remember only this format. Based on that you can very easily put the name for any organic compound. Okay, let's see here. So in the format you can see the first coming here is secondary prefix, or you can take it like this. There is a word root is there, okay? There is a word root, and anything that is coming before the word root is called prefix. Okay, so you can see here prefix is classified into two. There is a secondary prefix, then comes the primary prefix. So first secondary prefix should come, then come the primary prefix, then what should come? Word root should come, then anything after the word root is called suffix. That is also classified into two, that is primary suffix and secondary suffix. So first comes the primary suffix, then comes the secondary suffix. So let's see what these mean actually. So what is word root? Very simple. Whenever you select the parent carbon chain, and please understand that in the parent carbon chain, suppose there is 5 carbon. So for 5 carbon we will put some name actually. For 5 carbon we use the term pent. Okay, pent. Suppose if it is, there is 5 carbon. Suppose if there is only 4 carbon atom, then what we will say? So there are different terms. We can say bute. Bute is the for 4 carbon atoms. Suppose there is only 2 carbon atoms, then the numbering is eth. Okay, so that is what they are telling. Alk word according to the number of carbon atom in the parent chain. Alk word means that term pent. So I will say 1 meth, 2 means eth, then 3 means what actually? Prop. Then 4 means what? Bute. 5 means pent. 6 means hex. 7 means hept. 8 means oct. 9 means non, non, none. And 10 means dec. And if it is 11 means undec. 12 means dodec. Understood? So I will give you that table, don't worry. So that is what it is indicating. So this will give only whether it is meth, eth or bute, like that, nothing else. Okay. Now we will go to what is primary suffix actually. Suffix can be of any types. So they are telling it can be ein, it can be in, or it can be wine. That depends actually. So in your parent carbon chain, if they are linked only by single bond, then we should use ein. So that means with the meth what will come, suppose if it is eth means what will come there? Ein. Then I can say ethane. Suppose they are linked by, these parent carbon atoms are linked by double bonds, then we say ene, then ethene. Okay, sometimes by triple bond we say ethwine. There can be case where single bond, double bond and triple bond will be there. In that case what we will do? We will say eth1n, at position 1 there will be ene, and at position 2 there will be wine. Then we say eth1n and 2 wine. We will see the examples, then you will understand. Okay, so primary suffix stands for ein, een and wine. Then comes the secondary suffix. So secondary suffix, if there is a functional group, then we will put the secondary suffix as the, which one is the seniormost functional group in the priority table, its suffix will be kept. Normally, suppose if it is a carboxylic acid, COOH, so the suffix used will be what? Oic acid, OIC, oic acid. Now, similarly, before the word root, okay, before the word root, we will add prefix. Prefix is also classified into two, that is primary prefix and secondary prefix. And please remember, the primary prefix is only, there is only one term in that, that is cyclo, and this is applicable only for cyclo compounds. So I will write here the primary prefix applicable only for cyclo compounds. We will see. So if it is a linear chain compound, surely what will be absent? Primary prefix will not be there, because primary prefix is cyclo, that is applicable only for cyclo compounds. And what is secondary prefix? They are the substituents with the locants. For example, you can see here, while we are numbering at 2, 3, 4, you can see the substituent. Then that substituents are the secondary prefix. So who comes first? Actually, the secondary prefix, that is the substituents with its locants. Okay, then comes what? Actually, if it is a linear chain compound, word root will come. Then what it will come? Primary suffix will come. And if there is a functional group, secondary suffix will come. So this is the order you need to remember. Okay, so let's see one example, then it becomes more easy for you. Okay, so this is just for your understanding. I am writing an example, something like this: CH3, CH, Cl, CH2, COOH. So this is an example I am giving. Okay. Now how will you name it as per this format? So first I will choose, what is the methodology? First I will choose the parent carbon chain. So my parent carbon chain here is, you know that how to do this. So this is my parent carbon chain. What is the next step to follow? You should number it. So numbering, I know that this functional group should get the lowest possible number. So I put the numbering also. Now I need to name it. So naming, who comes first? Secondary prefix, that is substituents with the locants. So substituent here is chlorine. So its locant is 3. So I can write 3, okay, hyphen chloro. Always the locants and alphabets should be separated by hyphen. So 3 hyphen chloro, 3 chloro. So secondary prefix is over. Primary prefix is not applicable since it is a linear chain compound. Then comes the word root. So I will count in the parent carbon chain how many carbon atoms are there. 1, 2, 3, 4. 4 carbon atoms are there. So I know that the word root for 4 is but. Okay, now I have kept the word root also. Now the next step is what? Putting the primary suffix. Now I am see the linking of this one. This is linked by single bond, single bond, single bond. Everything is linked with a single bond. Then I know that it is ein. Okay. Now please listen. If there is a secondary suffix is there, that means functional group is there. Please remove the e. Okay. Otherwise you can stop there. E. Otherwise you should remove the e. So this is up to this I have completed. Secondary suffix, yes, functional group COOH is present. That means oic acid. So here the functional group along with its position you need to mention normally. So you can say according to the main functional group along with the locants. So I can say butane. So locant comes, locant is 1. So butane 1. So hyphen I have kept. What is the suffix? Oic acid. So oic acid. Understood? So 3 chloro, butane, 1 oic acid. This is the way you need to name it. So best method is, please remember the format. Please understand what this format each one is standing for. Then apply to any compound. You will get the answer. I hope you understood. Try to do many examples. We will come up with more examples. And if you have any doubt, get back to me. Okay. Thank you. Hi dear students. Good morning to you all. So in the last class we discussed the different rules for doing the IUPAC nomenclature. We have seen the priority table. Okay, hope you might have all seen that. And today we are going to discuss, and also you have seen the format of IUPAC, how to frame an IUPAC name. Now we are going to see different examples, because only by working out the examples the concept will become thorough for you. So we will do one by one examples and then we will go to the next topic. Okay. So see the example 1 here. So I am just starting with example 1. So I will put a tick here. So what are the things you should do? Steps, as a steps I will tell whenever you see a naming question. Okay. First thing to analyze here is whether functional group is present in this example. I could analyze that there is no functional groups present. Okay. That is gone. So the next thing you need to analyze here is, so functional group is not there means what is not there? You can say secondary suffix is not there. Correct. And next you need to analyze whether any double bond or triple bond is present in the compound. I could see there is no double bond or triple bond is present in the compound. Okay. So now the rule says what? You need to select the longest continuous possible chain, because there is no double bond, no functional group. So the next way is you need to select the longest continuous carbon chain. So let me say if I go in this way, like this, 1 2 3 4, only 4 carbon atoms are there. If I go in this way, 1 2 3 4, then also 4 carbon atoms are there. If I go in this way, 1 2 3 4 5 is there. Okay, remember. Now I am taking in this way, 1 2 3 4, only 4 are there. 1 2 3 4 5 is there. Now the last possible way is 1 2 3 4 5 6 is there. That is the longest continuous possible carbon chain. So I will start from here. Okay, so I will start from here, then I will go in this fashion. Okay, so this is my longest continuous parent carbon chain. So I have now chosen that. Now what is the next step? Next step is numbering. Correct. So on numbering we know that only substituents are there. Okay, outside this. Now we need to do the numbering in such a way that the substituents should get the lowest possible number, because there is no functional group or multiple bond present. So here if I do it in this way, I will put the number and see 1 2 3 4 5 6. So what are the locants coming for the substituents? Here one CH3, here one CH3. The locants coming here is 3, 4. Correct? And both are methyl group. Now suppose if I am rubbing this, okay, and I am going to number it in the other way. For example, like this, 1 2 3 4 5 6. Now listen, what is the numbers coming for the locants? Again it is 3, 4. That means it is a symmetrical molecule. So if you do it in this way numbering or this way numbering, in both ways the CH3 group is getting 3, 4. So anything you can choose. Suppose I am choosing this way, there will be no change in the name. Okay, so both are correct. Now numbering is completed. What is the next step you need to do? You need to name the compound. Correct. So we know the format, how to name it actually. You know that first word root should be there. Word root means 1 2 3 4 5 6. In the parent carbon chain 6 carbon atoms are there. So I can say my word root is hex. Hex is my word root. Now I will go to prefix. 1 degree prefix is applicable only for cyclo compounds. So it is not a cyclo compound. So there is no 1 degree prefix. Then what is applicable? 2 degree prefix. 2 degree prefix stands for substituents. And I know that here substituents are there. That is methyl is present at 3 and 4. So since 2 methyl is present, I will say diamethyl. Okay, and at what positions it is present? 3 and 4. So we know that first we need to say the locants, that should be separated by commas. So 3, 4. Correct? Then numbers should be separated from the alphabets by hyphen. So 3, 4 hyphen diamethyl. So secondary prefix is completed. No primary prefix. Word root I have added. And we know that next we are going for 1 degree suffix. 1 degree suffix means how the parent chains are linked, whether it is through single bond, then it is ane, double bond it is ene, and triple bond it means wine. Now I know that the parent carbon atom, it is linked through single bond. Then I can add ane, hexane. So I got the answer. The answer is 3,4 dimethyl hexane. Understood? Now we will try to see the next example. Okay. So in the next example, again the scenario remains the same. So what is the thing? We know that in the first step we need to check whether any functional group is present or not. I know that there is no functional group present here, correct? Then I am going to check for double bonds or triple bonds. There is no double bond or triple bond present in the compound. Then it is the same way. Then we need to select the longest continuous parent carbon chain. So I am trying to do that. 1, 2, 3, 4, 5, 6. Then 6 I will get. Here if I go like this, 1, 2, 3, 4, 5, 6. Then also 6 I will get. Then if I go like this, 1, 2, 3, 4, 5, 6. Then also 6 I will get. Do we get any possibility of numbers greater than 6? No, in all the possibilities we are getting 6 as the maximum count actually. If you have more than one counts of 6 is there, what is the rule saying? The rule says that you choose the parent carbon chain in such a way that it should contain the maximum number of substituents. So for example, now here I am going to choose this as my parent carbon chain. Okay. So you can see if I choose this as my parent carbon chain, 1, 2, 3, 4, 5, 6. Now how many substituents are there? Here one is there, here one is there, here another one is there, here another one. So you will get 4 substituents. And if you choose this one also, you will get 4 substituents. In all the way it is similar only. Okay. now what we will do, we will try to number it. So numbering, we should do that. So if I do it from left to right, 1, 2, 3, 4, 5, 6. So if I do it like this, what is the way the locants are coming? You know that CH3. So 2, 2, here 5, 5. So this is the numbering that is coming. If I do it like this, correct? Now suppose I am rubbing this, I am trying to find it in the other way. Okay. I am trying to do it in this way. 1, 2, 3, 4, 5, 6. In this case, what is the numbers coming? Again it is 2, at position 2 there are 2 methyl groups, so 2, 2. Then here 2 methyl group, then I can write 5, 5. So both are correct actually. Okay, so if both are correct, then I can choose any numbering. Both are almost similar. So what is the first thing? You look at the parent carbon chain. How many carbon atoms are there? 6 carbon atoms are there. So my word root here is hex. I can choose the term hex. Now I know that primary prefix is not there. Secondary prefix, that is substituents, yes, it is present. I know that at 2, 2 you have and 5 you have. So all are similar substituents. So all are similar means I can write 1, 2, 3, 4. I can use the term tetra. So how will you write? I can write 2, 2, then 5, 5. Then this should be separated by hyphen. Then what I can write? tetramethyl, parent, we know word root is hex. Then next thing I will go for primary suffix. All are linked through single bond. So my term will be ane. So hexane. So this is the IUPAC name for the second compound. So I hope you understood this example. If you have any doubt, please try it out. The best way to learn IUPAC name is try to choose the different path and check whether it is following your rules. Okay, otherwise it is not like you need to by heart for this compound, this is the pen. It's not like that. You should try it in different way, then only you will learn it actually. Okay, so I hope you understood. If you have any doubt, come back to us. So we will do the next examples. Okay, so hi students, so we will see the example 3. So example 3 is a very good example. Just if you analyze, you will understand that. Okay, I hope everybody could see the example 3 here. Okay, so what is the first step again? What you need to do? Check for any functional group. I have checked it. There is no functional group present. Then second rule, I am checking whether any double bond or triple bond is present. Yes, double bonds are present in the compound. Then the rule says that you should choose the parent carbon chain in such a way that you should include the maximum number of double bonds. Very, very important. Now I understood the rule. Now I am going to apply that. Now I am trying to see. Okay, suppose if I am going to say this is my parent carbon chain. Okay, straight way. Now many students will say, sir, if I choose this as the parent carbon chain, I have included only 2 double bonds. But the rule says that we need to include maximum number of double bonds. Please remember, they are using the term maximum number. It does not mean that you need to include every double bonds, because if it is possible, you need to include every double bonds, but if it is not possible, then you need to include the maximum number of double bonds, because here it is the longest continuous parent carbon chain. So if I choose this as my parent path, you can include only 2 double bonds. Then some students say, sir, then we will choose the other one. Then in that case, suppose if I am choosing this as my parent carbon chain, then what will happen? Here also you need to this double bond will not be included. You have chosen like this. So whatever way you have choose the parent carbon chain, for example, if I am choosing like this, okay, so some students say, sir, why can't it be like this? Okay, if I choose like this, then this is also correct, but the problem here is this double bond will be omitted. So anyway, if you are choosing a continuous parent carbon chain, you can at a time include only 2 double bonds. Understood? So that is the reason why, since the compound is symmetrical, in any way we are choosing only group that is coming outside here is CH2 double bond CH. You can choose any one as the parent path, whatever I have shown here. Okay, so there are some doubts students used to say. I will draw that one also for your understanding. Just listen. Some students used to say, sir, why can't it be like this? I am choosing like this as my parent carbon chain. Is it correct? Of course not. Why? Because this is not continuous in nature. You should choose in such a way that it should be a continuous parent carbon chain. So some students say, sir, why this is also continuous, right, sir? No, not at all. So it can be like this, but here you could see there is no bending or there is no deviations or nothing is there. Here you can see typical deviations are there. So that is not possible. So this is not correct. It can be like this. You can choose like this, no issues. You can choose like this, no issues. But you cannot choose like this. This is not possible. Understood? So I hope you got a fair idea. Now we will choose the parent carbon chain. This is very important. That's the reason why we are discussing examples of this type. Okay. So let me say this is my parent carbon chain. Okay. So I have chosen that. Now the next step is what? I need to number the compound. So numbering means, how should I number it? So I know that I should number in such a way that the double bond should get the lowest possible number. So if I number it from here, 1, 2, 3, 4, 5. So what are the numbers coming here for double bond? 1 and 4. Now if I number it like here, 1, 2, 3, 4, 5, then here also 1 and 4 is coming. So anyway you can number it. It is not an issue. So 1, 2, 3, 4, 5. In both ways 3 is the number coming for the substituent. Now next question is how I will name the substituent. This is not a simple substituent. This is a complex substituent. So how I will name that? Listen here. This compound is which one actually? You know it, CH2 double bond CH2. Since 2 carbon atoms are there, I will put eth, and since double bond is there, I will put ethene. Correct? Now if I am removing one H from here, so in that case we use the term ethynyl. What it is? Ethynyl. You can remember like this. What is this compound? Methane. Correct? Methane. So it's a alkane. So in alkane, if you remove H, it will become what? Methyl. Similar, ethene, you remove the E. Okay, I will write here. Remove E and put YL. So remove the E and put YL, and similarly here remove the H, once you remove the H, remove the E and put YL, so it becomes methyl. So this is the way you need to put the substituent's name. Okay, so next we will try to see how to name it actually. So here we will see. So I know that word root means 1, 2, 3, 4, 5. So 5 people are 5 carbon is there, so I will use the term pent. Okay, and I know primary prefix will not come into picture because it is not a cyclo compound. Now what is the next thing you need to remember? Secondary prefix. Secondary prefix will come because there is substituent is there. So how will you put the substituent? We know that 3-ethynyl. 3, what should be there? Hyphen ethynyl. 3-ethynyl pent. Now I am going for 1 degree suffix. 1 degree suffix, I know the parent carbon atom chain is linked through double bonds. So I should put that in what at all position double bond is there at position 1 and position 4. So I can say pent 1, 4. Okay, you need to put hyphen after alphabets. Then locants should be separated by commas. Pent 1, 4. Then hyphen. We know that 2 double bonds are there, so I will use the term di. So this much will come here. Then we know that primary suffix is in, wine, ain. So here, since double bonds are there, I will use the term in. So I can say di-ene. So this will be the IUPAC name of this compound, 3-ethynyl pent 1, 4 diene. Okay. So next we will try to see the other example. And here you need to remember one more thing. You will remember, you will see that in the chapter haloalkanes, this group has a common name also, CH2 double bond CH. Its common name is there. So sometimes they may give that also. That is called vinyl group. This group is called vinyl. So some question paper will say 3 vinyl pent 1, 4 diene. That is also correct. But more correct is this one, 3-ethynyl pent 1, 4 diene. Okay, so we'll go to the example 4. So in the example 4, first thing what we need to look, we need to see whether any functional group is present. So I could see there is no functional group is present. What is the next thing you need to see? Whether any double bond or triple bond is present. Yes, double bond is present. Now you need to choose the path, I mean the parent carbon chain in such a way trying to include the maximum number of double bonds. So if I go like this, 1, 2, 3, 4, so only 4 will come. Now if I go like this, 1, 2, 3, 4, 5, 6, okay, I will get 6 including the double bond. So this should be my parent carbon chain. So this is continuous in nature. Okay, so this is my parent carbon chain. Now what is the next thing I need to do? I should do the numbering. So if I see here numbering 1, 2, 3, 4. So 3 and 4 are the locants coming. Okay, now if I do it in the other way, 1, 2, 3, 4, again 3 and 4 is the locants coming. So I can number it in any way, 1, 2, 3, 4, 5, 6. I hope you understood. Now what is the next thing? We will start naming. Word root, 6 carbons are there, so I will use the term hex. Correct? Primary suffix will not come into picture since it is not a cyclo compound. So I will go for what? Secondary prefix. So secondary prefix are substituents. At what position substituents are there? 3 and 4. Since it is the same substituent, I can use the term di because there are 2 same substituents are there. So I can write, what, tell me, 3, 4 dimethyl 3, 4. So I should put hyphen 3, 4 hyphen dimethyl. Okay. Then parent carbon chain has 6 carbon atoms, so hex. Now double bond is there. At what position double bond is there? Between 3 and 4. The minimum number is 3. So I can say hex hyphen 3 hyphen ene. So 3, 4 dimethyl hex 3-ene. Always specify the position of the double bond or triple bond. Sometimes in some question double bond and triple bond will come. In that case ene and wine should be there, but always remember it should be as per the alphabetical order. First you need to mention ene, then followed by wine along with its locants. Okay, always remember numbers, they should be separated from the alphabet by hyphens, and if there are multiple numbers are there like 1, 4, you should separate the numbers by commas. Okay, so I hope you understood this example. We will go to the next examples. So we'll go to the next example. I hope this is example okay, I am not remembering the number. Okay, so we'll go to this one. So this is the question here. From here, example 3. Okay, so the first step, what you need to do, you need to check for whether any functional group is present in the given compound. No, it is not there. What is the next thing to check? Whether any double bond or triple bond is present. Yes, double bond and triple bond is present. Then the rule says that try to select the carbon chain in such a way that you should include the maximum number of double bonds and triple bonds. So I understood that I should choose the parent carbon chain in such a way that I should include double bond and triple bond. The only way that is I should choose the parent carbon chain in this way, because if I choose like this, then only both double bond and triple bond is included. Correct? So this is my parent carbon chain. So next we will try to do the numbering for this compound. So here one question will come. Here triple bond is present, double bond is present. So if I do the numbering in this way, okay, let it be like this: 1, 2, 3, 4, 5. So in this numbering, I know that for double bond 1 is coming, correct, and for triple bond the minimum number coming is 4, correct. Suppose if I am not following this, I am doing it in the other way. So if I am doing it in the other way means 1, 2, 3, 4, 5. So here 1 is coming for the triple bond and 4 is coming for the double bond. So that means it is a case of symmetry. Symmetrical condition is being followed. So we know that as per the rule, if there is a condition for symmetry, then always give priority to which bond? Double bond. That means double bond should get the lowest possible number. So I will remove this again and I will choose the other one, that is 1, 2, 3, 4, 5. In both cases the substituent is getting the locand 3. Okay, so I hope you understood the numbering. Now next thing is what? Putting the name. Now look at the parent carbon atom. How many carbon atoms are there? 5 carbon atoms are there. So I will use the word root pent. Now 1 degree suffix will not come since it is not a cyclocompound. 2 degree prefix will come because there is a substituent at position 3. So what is the substituent at 3? You can see 3 ethyl, CH3CH2. So I can add 3 hyphen ethyl. Okay, one more thing I need to remember you. Whenever you start the naming, the first letter should be capital letter. So 3 hyphen E is a capital letter. In the previous examples I have written in small letter, so please correct it. So first in the word, in the naming, the first letter should be always a capital letter. Okay, so 3 hyphen ethyl penned. Now I am looking at the double bonds. At position 1 there is a double bond and at position 4 there is a triple bond. So I know that for double bond ene and for triple bond wine. So who comes alphabetically first, ene or wine? It is ene. So I can say penned hyphen 1n. I should not write ene because there is wine is also there. So I will remove the last e from this. Penned hyphen 1 hyphen n. Then again the position of the triple bond, that is 4, then hyphen, then wine, because there is nothing else at the end. So wine. So this is the IUPAC name. 3 ethyl penned 1n 4 wine. Understood? So this is the way you should do the IUPAC naming. Now we will go to the next example. Now looking at the next example, one important thing you can see, there is no functional group but there are double bond and triple bond present, and this is a previous NEET question also. Okay, and we know that it is very easy to choose the continuous parent carbon chain because there is no branching. So I can say this is my parent carbon chain. Correct? Now the question here is numbering. So here also if I do the numbering in this way, 1, 2, 3, 4. So what is the locants coming for the triple bond? It is 1 here, and for double bond it is 3 here. Okay. Now if somebody removes this and do it in the other way, 1, 2, 3, 4. Now what is the position coming here? For double bond 1 and 2, so minimum number is 1, and for triple bond it is 3, and for the minimum number is 3. So again 1, 3, 1, 3. So it is again a case of symmetrical condition. So when symmetrical condition comes, always the priority goes to whom? Double bond. That means the double bond should get the lowest possible number. So this is the correct way of numbering. Understood? Now what you need to do, so next thing is naming. So word root, 4 carbon atoms are there, so I will use the term bute. Correct? and 1 degree prefix will not come since it is not a cyclo compound, and 2 degree prefix also will not come. Why? Because there is no substituent outside the parent carbon chain. So what is there next? You have 1 degree suffix. So 1 degree suffix means you have double bond and triple bond. Ene and wine is there. Again the same thing. Alphabetically ene should come first. So but, I can say 1-1n-3 wine. Understood? So but 1n-3 wine. So here you should remember this B should be capital letter. But 1n-3 wine. So this is the way you need to name it. So many students will get this wrong because they will give priority to triple bond and do it. So please remember the IUPAC rule. When there is a symmetrical condition, then you should follow what? Priority should be given to whom? Double bond. Okay. So I hope you understood both the examples. Now we will go to the next examples. So here we will try to see the next example. Okay. So in the next example, you can see here CH3, CH double bond, CH single bond, C triple bond, CH. So here again there is no branching, so it is very easy for me to choose the parent carbon chain. So this is my parent carbon chain, correct? Now the next step here is doing the numbering, very important. So suppose I am doing the numbering like this: 1 2 3 4 5. So what is the double bond number that is coming for the double bond? 2 and 3 minimum number is 2, 4 and 5 the minimum number is 4. So 2, 4 is the numbering coming here. Okay. Now suppose somebody do the numbering like this. Okay, 1 2 3 4 5. Now tell me the minimum numbering coming for triple bond is 1, and for double bond it is 1, 4, 3 and 4 it is 3. Now tell me, as per the first point of difference rule, which should be the correct numbering. So here itself the first difference is there and the minimum number here is 1. So this should be the correct numbering. Understood? So many students here have a doubt. Sir, they will say, sir, priority should be given to the double bond, right? So in the first way of numbering, the number that is coming for the double bond is 2. So that should be the correct, right? Many students will ask, but it is not correct. Why? Because the priority will goes to double bond only if there exists a symmetrical condition. Here you can say 2, 4 and 1, 3. That is not symmetrical. Both should be identical. Then only we say it is symmetrical. So here 1, 3 should be the correct numbering. Understood? So how to do it? 5 carbon atoms are there. So 5 carbon atoms means what is the number? Pent should come. Correct? Okay, since that is the first letter, so I will use the capital letter here. Since you know that there is no primary suffix, it is not a cyclo compound. Secondary suffix is not there because there is no branching present. So pent, tell me, there is ene and wine. So who should come alphabetically first? Ene should come. At what position? 3. So I can write pent -3 n-1 wine. Understood? So this is the IUPAC name of this compound. It's very easy. Once you thorough with the rules, it is very easy. You can easily apply it, but always try to explore it, try to do it, experiment, then you will learn more. Because I am teaching this for last 8 to 10 years, so I know it. What is the answer? So I will not try to experiment much, but I will give you some other lectures where I am trying to show the all possible ways, so that it will become a belief in you. It is correct. Otherwise, always have some doubts, or it is correct or not, like this. Okay, don't worry about it. We will do as much as practice as possible. Okay. Now we'll go to the next question. So in the next question, again the first question to be answered is whether functional group is present or not. Yes, functional group is present. So the next question here is, sir, whether it's a carbon containing functional group or not. Yes, it is a carbon containing functional group. Then the rule says that you should start selecting the parent carbon chain from that particular carbon atom and try to include the maximum number of double bonds. So I can say this is where I will start. Then I know there is double bond is present, so I should include that also. So this is my parent carbon chain. So here many students will come up with a doubt. I will say that, sir, if I choose like this, 1 2 3 4 is only there, but why can't it be like this, 1 2 3 4 5, then 5 will come, right? But that is wrong. Why? Because in that case we are not including the double bond. The rule says that the priority order is try to include first the functional group, then the next priority goes to whom? Double bond or triple bond, then only it is the number of carbon atoms. So the first priority COH we have given, then we try to include the maximum number of double bonds. So this is the parent carbon chain. Now next thing is numbering. It is very easy for us to number. Why? Because whenever functional group is there, that functional group should get the lowest priority number. So it is very easy. 1 2 3 4. Now again the same way you can name the compound. 4 carbon atoms are there. So 4 means what? You use the term but. Correct? But. And primary suffix not applicable. Secondary suffix, yes, it is present. At position 2 there is methyl, and at position 3 there is ethyl is there. So methyl and ethyl, who comes alphabetically first? Ethyl will come first. So I will write like this: 3 hyphen ethyl, then what you say, hyphen 2 hyphen methyl. Correct? So 3 ethyl, 2 methyl, then what you will say, hyphen, no, there is no hyphen required, 2 methyl, parent but, at what position? At position 3, but 3, then what is coming there? Double bond, but 3n. Actually I can write but 3, but not correct, because here functional group is also present, so you need to put the suffix of the functional group. So but 3n, at what position? Position 1, say 1, but 3n 1, what is the suffix? Oic acid. Correct? So the complete name is 3 ethyl 2 methyl but 3n 1 oic acid. So some people used to say 3 ethyl 2 methyl but 3 enoic acid. That is also correct, since it is position 1. Somebody, they will not explicitly say. That is also correct, but exact correct way is this one. You need to write this along with this one. There is no space, that's why I am writing in the down. Okay, so I hope you got a fair idea how to do this. We will do more examples, then you will get a complete picture. Okay, hi all. So let's see the next example. Okay, I hope you could see the board clearly. Okay, so we will try to answer how to put the IUPAC name for the first compound. So you have given a compound. So first thing to be checked here is what? Presence of functional group. Important. So we could see here COH group is a functional group, and we could also see there is a carbonyl group also. So we know that as per the IUPAC rules, when there are multiple functional groups present in an organic compound, then one of the functional group will act as the main senior most functional group, and the other functional group will behave like a substituent. Now who will be the main functional group? Now you can go into the priority table and check carboxylic acid and carbonyl group is there. Who comes first in the priority table? You know that it is carboxylic acid. So I can say this is the functional group here. Okay, so this is the FG. I will say this is the functional group, and this will behave like what? Actually here it will behave like a substituent. Very important. Okay, now we will try to choose our parent carbon chain. You know that if it is a carbon containing functional group, you need to include that carbon also in the parent carbon chain. So I have included that. Now this is my parent carbon chain. Now tell me how many carbon atoms are there in the parent carbon chain? 1 2 3 4 5 6, or 1 2 3 4 5 6. So 6 carbon atoms are there. So I will put the word root as hex. Now there is no primary suffix since it is not a cyclo compound. Secondary suffix, is there any substituent? Yes, there is a substituent. So it is at what position? So we need to number it actually. So tell me how we number it. We know that whenever functional group is there, it should get the lowest possible number. So I will give 1 to this 1 2 3 4 5 6. So I know that in the fifth position there is a substituent. So I know that, okay, carbonyl group, it behaves like a functional group, means you will put the suffix ONE, on. You can refer the priority table. Now the same carbonyl group, if it behaves like a substituent, then we use the term prefix. So what is the prefix used there? Oxo. Okay, so I know that this is at the fifth position, so I will write 5-O-5-oxo. Okay, so I have kept that. Then comes the word root, that is hex, 5-oxo hex. Now we will see all are linked by single bond, so I know that it is ANE, correct? But you need to remember here there is functional group, so there is secondary suffix is also required, correct? So I can remove the E. Then I know the position, at which position the functional group is present, first position, so I will write hexane 1. Then I know what is the COOH, if it behaves like a functional group, what is the suffix? Oic acid. So I will put here oic acid. So I got the answer, that is 5-oxohexane 1-oic acid, or even you can say 5-oxohexanoic acid, since it is 1, not mandatory. Understood? So this is the way you need to name the compound. Now we will go to see the next compound. So here again, what is the fundamental? The fundamental says that you need to look for the functional group. So you can see here there is no functional group present here, correct? No functional group. Then who will get the next priority? Multiple bonds. So you have a multiple bond here, then you have a substituent here. So I know this is my parent carbon chain. Okay, so this is my parent carbon chain. Now while numbering, who should be given priority, substituent or multiple bond? You know that the priority order is multiple bond, then only substituent comes. So I will put 1 here, then 2 here, then 3 here. Now first we will put the word root. 3 carbon atoms are there, so we will use the term, okay, prop. Okay, and we know that primary prefix will not come because it is not a cyclo compound. Secondary prefix it will come because there is a substituent at position 3. So I can write, how I can write 3-bromo, 3-bromo, word root prop. Now I know that all in the parent carbon chain they are linked by double bond at position 1. So I can write prop 1-ene. So here why I am writing ene, because there is no secondary suffix is not there, no functional group. So I can write prop 1-ene. So the answer is 3-bromo prop 1-ene. Hope you understood. So next we will go through different functional groups and we will take examples of each one and we will do it. This is very important. You need to know the naming, then only you can play with organic chemistry. Okay. Hi students, so next we are going to discuss the bond line notation, very important. It is a way of representing your organic compounds in a more condensed way, that is called bond line notation. Okay, so this is very important. After this we will go to different classes of compounds, because usually for NEET they will, if they are asking a question from IUPAC, usually they will give bond line notation. So this is very important for you to understand. So I will tell you the shortcuts how to understand that. Okay, so let's see here. So bond line notation, starting with very simple, I will start with a straight line. Okay, just to remember like that, it's very easy. So this is just a straight line. So whenever there is an opponent in a line, so that indicates CH3 group. Okay, so this indicates CH3, and here there is another opponent, so this will also be CH3. So what is the compound then? We can write this is nothing but CH3-CH3, correct, or C2H6. That is the condensed formula. Now another way to remember here is, you can say this is my carbon, this dot denotes carbon, and there is only one line moving out of it. That means only one valency is replaced. So we know that carbon has 4 valency. So one valency is replaced means how many hydrogen will be remaining? 3 hydrogen. That is another way to remember CH3. Here also you can take it another here way. So here only one line is coming out of it. That means only one hydrogen is replaced. That means you know carbon has 4 valency. So instead of CH4, one H is replaced. So CH3 is coming. This is the one way to remember. Now we will see the next denotation. Okay, think like this is how they have given. Okay, now you could see here, whenever a dot is there, a joint is there or a dot is there, that indicates carbon atom. So how many carbon atoms are here? 3 carbon atoms are here. So here you can see an open end. Open end means it is only one line is moving out of it, or you can say only one line is going out of it. So that means this is CH3. Now here if you see, here also only one line is moving out of it. So this is also CH3. Correct? Now if you look at this carbon atom, it has 2 lines moving out of it. So that means 2H is replaced. So this should be what actually? CH2. So the compound here is what actually? CH3, CH2, CH3. Understood? So this is the easiest way to remember actually. Okay, now we will try to see the complicated stuffs. Okay, so I hope you understood this. Please note down also. Okay, so we will go to the next one. Suppose if it is like this. Okay, so if it is like this, how will you interpret this one? Very easy to remember. So looking at the free end, first we will start with the free end, only one moving out. So it is what actually? CH3. Here also it is one only moving out. So this is what? CH3. Here also one is moving out. So that is CH3. And here you can see a joint. So 3 is coming out of it. 3. So 3 valency is replaced means out of 4, now only remaining is CH. We know that carbon has 4 valency, so 3H is replaced. Since 3 rays are moving out, so it will be CH. So how I can write the formula? CH3, CH, CH3, CH3, correct? CH3. So this is the actual diagram. So this is the way they can represent it. Now we will see the last formation. Okay. So suppose if it is like this. Okay, so it's familiar symbol, right? So here you could see it is an open end. So this should be what? CH3. This is another open end. So it should be what? CH3. One only moving out. So here also you could see this is CH3. Only one is moving out. So, okay, so here another one. So only one. So it should be CH3. So central you have 4 guys. In central carbon atom 4 are replaced. So central it should be carbon alone. So what should be the way? CH3, CH3, this is CH3 and this is CH3. Understood? So this is the way you should understand the bond line notation. Now we will see how the double bonds are represented. Okay. Now let's start with a simple example. Okay. Okay, so think about this. Whenever double bonds are there, something like is this, I will give you a shortcut. The better way is you cut this into slices. Wherever the double bond starts, put a slice. Wherever the double bond ends, put a slice. Again go here, here double bond is starting, put a slice. Here double bond is ending, put a slice. Then mark these points as carbon atoms. These are carbon atoms. These are carbon atoms. These are carbon atoms. Now next thing here is you could see 2 rays are coming out of it. Okay, 2 rays are coming out of this carbon atom. That means 2 valency is replaced. So this should be what actually? CH2. Then double bond. I am looking at this carbon atom. 1 ray is here, 1 ray is here, 1 ray is here. So 3 has bent. So remaining is 1. So I can put CH. Then again single bond. Coming to here, 1 ray gone. Here also 1 ray, here also 1 ray. So total 3 rays. So this should also be CH. Then double bond is there. Then coming to this one, there is only 2 rays coming out of it. So remaining should be 2 hydrogens. So this should be the formula. Understood? CH2, CH, single bond CH, double bond CH2. So this is the way we interpret double bonds. Now we will see a triple bond. Okay. So let it be like this. Okay, this be the example. Now again the concept is same only. First slices into pieces. So I have sliced starting, ending. Again this is starting and this is ending. Again this is starting and this is ending. Do it like this. Then what you need to do, then now mark the carbon atoms. Now these are carbon atoms. This is carbon atom, this is carbon atom, carbon atom, carbon atom, carbon atom. Now looking at this one, there are 3 rays moving out of it. 1, 2, 3. So 3 means only 1 is remaining, so I can put CH. Okay, then triple bond. Then coming at this one, this is 1, this is 2, this is 3, this is 4. 4 rays are moving, so there is no H here. I can put a single bond. Now here coming at this carbon atom, again 1, 2, 3. 3 rays are moving, only 1 is remaining, so I can put CH, then double bond. Okay, coming at this carbon atom, again 3 rays, so this should be CH, then single bond. Then coming at this one, this is having 4 rays, so it should be C, then triple bond. Here coming at, there is only 3 is there, so this should be CH. So this is the way you need to interpret the bond line notation. I hope you understood. If you have any doubt, please come back. Okay. Then another important thing, sometimes they will represent the functional groups also in bond line notation. For example, you know this is carboxylic acid, COOH, correct? This is carboxylic acid. Now this can be represented in different way. Sometimes they used to represent this by C double bond or actual structure OH. This is one way of representing. Okay, so the same way they can use it here also in bond line notation. How they will use? They will use it like this, C double bond O OH. So this area indicates what actually? Carbonyl group with the hydroxyl group, that gives you carboxylic acid. So this is nothing but my COOH group. So you can expect something like this in the bond line notation. Okay, all these are important tips for you to understand the bond line notation. Now I hope you understood the bond line notation. We will do some examples for your understanding. Okay, now starting with simple example. So can you name this compound? What is the name of this organic compound? Very simple. Again, as I told, put joined here, joined here, joined here, here also joined, here also joined, here also joined. First of all, look for the functional group. Is there any functional group present here? No. Is there any multiple bond present here? No. Then we know that the parent carbon chain should be longest continuous possible parent carbon chain. So I will count 1, 2, 3, 4, 5. One possibility. 1, 2, 3, 4. 1, 2, 3, 4. So which should be my parent carbon chain then? So I have identified my parent carbon chain. So this is my parent carbon chain. So I got my parent carbon chain. So next step is numbering it actually. So there is no double bond or functional groups, then who should get the priority? Substituent should get the priority. So if you number it from here, 1, 2, 3, 4, 5, 3 is the number coming. If you number it from here, 1, 2, 3, 4, 5, again 3 is coming. So there is no point in numbering from left to right or right to left. So let's say we are numbering from left to right. So 1, 2, 3, 4, 5. Now tell me, if there is 5 carbon atoms, what is the term using? Pent. Correct? There is no primary suffix, there is no primary prefix, and secondary prefix is there, that is substituent at third position. So I can start with 3 hyphen methyl, because this is CH3, you know, it's opponent, so it should be CH3. So 3 methyl, correct? Now word root is there, pent, and all these are linked through single bond. So it should be pentane. So this is the way you should understand what bond line notation. Now we will see more examples for your familiarization. Okay. So next we will see some more examples. So you could see first example here. So this is also a previous NEET question. So in the first question again, what we need, the first thing to look for, functional group. I could see there is no functional group present here, correct? And looking for the multiple bonds, yes, there is a multiple bond present here. So we need to include this multiple bond, these two carbon atoms in my parent carbon chain. So let's start from there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so suppose if I go by this way, 1, 2, 3, 4, 5, 6, then it is 6 carbon atom. If I go by this way, 1, 2, 3, 4, 5, 6, then also 6 carbon atom. 1, 2, 3, 4, 5, 6, then also 6 carbon atom. Now I can eliminate this path, that is this one, 1, 2, 3, 4, 5, 6. This path I can eliminate. The reason for that is, suppose if I am choosing this as my parent carbon chain. Okay, suppose I am choosing this as my parent carbon chain. The problem here is, we know that anyway all the three cases you are including the multiple bond, there is no doubt. If after the multiple bond, who is having the next priority? The next priority is given by substituents, and we know that whenever there are multiple paths possible, we should always try to find the path that should have the maximum number of substituents, you remember. Okay, so if I choose this path, how many substituents are there? There is only one substituent, that is this big group, correct? But if I am choosing the other one, okay, let's see what is that. Very important in naming, there can be mistakes, but you should analyze it. Only that rules should be kept in mind. So suppose if I am choosing this path, okay, so I am choosing this one, okay, so if I am choosing this as my path, then you can see here there is one substituent in this direction and there is another substituent in this direction. That means two substituents are there. So, and double bond is also included. So that should be my principal parent carbon chain, because the rule states that if there are multiple ways you can select the carbon chain, then you should select that carbon chain which should contain the maximum number of substituents. Please refer to my old theory and example. There you could see I have discussed that rule. Okay, now how to number it? You know that multiple bond should get the least priority number. So 1, this is 2, then it should have 3, then this is 4, then this is 5, then this is 6. Okay, so 6 carbon atoms are there. So I will put the word root as hex. Now primary prefix is not there, secondary prefix will be there because there are substituents. At third position you can see what is there, 1, 2, 3, there is a propyl group, 3 carbon atoms. So I can say at third position propyl is there, and at fourth position you can see 1, 2, ethyl group. So who comes first in the alphabetical order? It is ethyl. So I can start with 4 hyphen capital E, ethyl. Okay, then hyphen third position I can say propyl is there, hyphen propyl, then word root is 6 carbon atoms, so hex, and I know that there is double bond in the parent carbon chain, so that should be there at position 1, so hex hyphen 1 ene. Understood? So this should be my IUPAC name of the compound. Okay, so some students say, sir, why don't you include this as the parent carbon chain? If you include this, the same name you will get. There is no difference. You can try it out. Okay, now next one coming to here. What should be the name of this compound? So before you put the name of this compound, we can say functional group is there, correct? 2 functional groups are there, COOH and OH is there. So whenever multiple functional groups are there, the priority should go to the one that is present senior most in the priority table. Here we know carboxylic acid, which has the highest priority. So anyway, this should be, we should start our parent chain with this carbon atom. Now we know that after carbon is included in the parent carbon chain, then we should try to include the maximum number of double bonds and triple bonds. So it should be coming like this, then only you can include this. So you have included the double bond and you need to include the triple bond. because that has the priority. And many students will ask, sir, why don't you include OH? Because OH, whenever there is principal functional group is there, this OH should behave like what? It should behave like a substituent. I have told, whenever multiple functional groups are there, the one which is the senior most in the priority table behaves like the actual functional group, and the other functional groups behaves like substituents. And now you know that OH is a substituent and these are multiple bonds. As per priority, multiple bonds comes first, then only substituent. So that's why multiple bonds are included in the parent carbon chain. And you know that this OH group, it's a without carbon, so that carbon is also included in the parent chain. Now how to name this? We will start numbering. So this is my first, this is my second carbon, this is my third carbon, this is my fourth, this is my fifth, and this is my sixth. Correct? So parent chain has 6 carbon atoms, so it should be what actually? There should be hex. Now primary prefix is not there, secondary prefix it is there. Substituents are present at 4th position, 3rd position and 2nd position. So 3rd position, who is the substituent? 2 carbon atoms are there, correct? 2 carbon atoms, so it should be ethyl. Then in the 2nd position only 1 open carbon, so it should be methyl. And in the 4th position it is OH group. OH group, when it behaves like a substituent, we use the term hydroxy. So this is hydroxy, this is ethyl, and this is methyl. Who comes first in the alphabetical order? You know that it is ethyl. So I can start with saying that, okay, 3, okay, hyphen ethyl, okay, 3 ethyl, then hyphen. Next comes who actually? Hydroxy, H, and this one is there, methyl is there. So who comes first? A, B, C, D, E, F, G, H, I, J, K, L, M. So H will come, correct? Okay. So that will be 4. I can say 4 hydroxy. Tell me 4 hydroxy. Then comes 2 methyl. Okay. 2 methyl, there is no space there, so I am writing down methyl. Word root hex, hex. Now all in the parent carbon chain, they are linked through double bond and triple bond. I know that when ene and wine are there in the parent carbon chain, who comes alphabetically first, ene or wine? Ene. So ene is present at 3rd carbon, 3 and 4, so 3. So hex 3n, correct? And 5 and 6, wine is there. So 5th position I will choose 5 hyphen yn. Is it ending there? No, because you need to put, and now you have kept the primary suffix. Secondary suffix is there because functional group is there. At what position? 1st position. So again I am writing hyphen 1 hyphen oic acid. Oic acid. Understood? So this is the way they can ask you questions. So 3 ethyl, 4 hydroxy, 2 methyl, hex 3n, 5yn, E should be removed, 5yn, 1 oic acid. This is the answer. So I hope you understood. Please revise it as much as possible, then only you will learn it. If you have any doubt, please get back to us. Thank you. Hi. So let's see few more examples, because examples are very important. Okay. So coming to the next example, you can see here double bonds are there. There is no functional group and there is no branching. So this is my parent functional group, or sorry, this is my parent carbon chain, correct? Now how many carbon atoms are there? As you know, by slicing we could understand 2, 3, 4 carbon atoms are there. So 4 carbon atoms means I know the term should be what actually? But, correct? And when you number it, if you number it by this method, 1, 2, 3, 4, or if you number it in the other way, 1, 2, 3, 4, again the numbers are similar, 1 and 3, and the other way also it is 1 and 3 that is coming. So this should be okay, fine. So tell me how to do this. We know that there is no substituents, so there is no secondary prefix, no primary prefix, because it is not a cyclo compound. Word root I have written but, so I can write this as a capital letter, but. Then at what position? But 1, then comma 3. Why I am putting comma? Because both are double bond. But 1 comma 3, then hyphen di. Why di is coming? Because both are double bond. Diene. Correct? So some people used to say but 1 comma 3 diene, or there are other guys who say 1 comma 3 butadiene. This is another way of telling. Both are correct, but this is more correct. Accepted one. This is also accepted these days. Okay. So I hope you understood how di is coming, because both are similar double bonds. If similar both methyl group means then also we will use di. If 3 are similar, tri. 4 are similar, tetra. Like that it will come. Okay. And very important point to remember here is di, tri, tetra. Those things are not considered for alphabetical comparison. If you want to compare with other substituent, don't take the D of the di. You should take the other one. Okay. That you should keep in mind. So next thing, the next example you could see here. This is a good example. Now here if you see, again there is no functional group present here. Multiple bonds are present, of course. So we should choose the parent carbon chain in such a way that it should have the maximum number of double bonds and triple bonds. So I will start from here. 1. So it should be like I am including this and I am including this. So this should be my longest possible double bonded including parent carbon chain. Correct? You can see 1, 2, 3, 4, 5, 6, 7 and all double bonds and triple bonds are included. Correct? So numbering. So let me start numbering from here. If I number it from here, 1, 2, 3, 4, 5, 6, 7. So what is the locant of the double bond? You know that 3 is coming, correct? Then for triple bond, what is the, then who comes next? Triple bond, you have the locant as 6, then substituent you have 3 again. Correct? Now suppose if I am doing the numbering like the other way. Okay. So if I am doing the numbering in the other way, that is 1, 2, 3, 4, 5, 6, 7. Okay, from this itself I understood 1 is coming here. 1, then 4, then 5. Correct? 1, 4, 5. So from this first point of difference rule, this is the minimum number. So this should be the correct numbering. So this is my correct numbering. This is wrong. Understood? Now naming. Tell me, parent carbon chain has 7 carbon atoms. So I use the term hept. Correct? There is no primary suffix since it is not a cyclo compound. Secondary prefix, it is there. Substituents are there at the position 5. So at the position 5 you could see one opponent. So it is 5 methyl. So I can say 5 hyphen capital M methyl. Correct? 5 methyl hept. You can see double bond and triple bond are present there in the parent carbon chain. We know ene and wine, alphabetically ene should come first. So at 4th position, so hept 4 N hyphen first position 1 wine. Correct? So I got the answer. So this is how you used to identify the IUPAC name. I hope you understood. If you have any doubt, get back to us. Hi, so let's see the next example here. So in the next example also, if you see, you can see a double bond present. There is no functional group here. So we can choose the parent carbon chain that includes the double bond. So let me say I am choosing the path. Okay, something like this. So from here, if I go in this way or this way or this way, all are similar. So let me say the straight path. So I am taking it like this, and this is my parent carbon chain. Correct? Now next thing is the numbering. So numbering, you can see here double bond should get the lowest possible number. So I should not start from here. If I start from here, 1, 2, 3, 3 is the number coming. But if I start from here, 1, 2, 2 is the number coming. So I should say 1, 2, 3, 4, 5. Correct? Now how I will put the name? I know that parent carbon chain has 5 carbon atoms. So I will use the term pent. And there is no primary prefix. Secondary prefix will be there because substituents at 4th position, 3rd position it is there. So at 4th position you have 2 methyl group and 3rd position you have a methyl group. So I can say when numbers are there, you should write it in increasing order. That is 3, 4, 4. All are methyl group. So I can say trimethyl. So I will write 3, 4, 4 hyphen tria. Okay. trimethyl. Parent chain has 5 carbon atoms, so I will write pent. Okay, now tell me at which position double bond is present. At 2nd position, pent 2 in. This is it. 3, 4, 4 trimethyl pent2ene. This is the IUPAC name of this compound. Now let's see how to do this one. So there is no functional group, there is no multiple bonds, nothing. So longest possible continuous parent carbon chain. So I know that from seeing itself. 1, 2, 3, 4, 5, 6, 7. So this looks my parent carbon chain. So I will choose that as my continuous parent carbon chain. Correct. Now I need to put the numbering. So since it looks like a symmetrical compound, if I start it from here or from here, the central will get the same number. So let's start from here. 1, 2, 3, 4, 5, 6, 7. So now I understood that at fourth position you have a substituent. Two substituents are there. That is, 2 carbon atoms are present. That means it is an ethyl group. Okay. And there is nothing else. So I can say 7 carbon atom means it should be hept. Okay. There is no primary prefix, secondary prefix. It is there. Substituents at fourth position. So we say 4, 4. Why we say 4, 4? Because 2 substituents at the same position. 4, 4 hyphen. What I can say? 4, 4. Di. Both are same ethyl. So I can say diethyl. 4, 4 diethyl. Now word root hept, and these are all linked through single bond, so I can say ane, heptane. So 4, 4 diethyl heptane will be the IUPAC name of that structure. Okay, so like this we can draw n number of structures. It's all about understanding the rules and applying it in the correct way. Okay. Hi, so let's see the next example here. Okay, so here, so if you see here, the first one, if you look into this one, there is a functional group present here, correct? And double bond is also present, and we need to see here the functional group present here does not include carbon. So this is connected to one carbon atom, that should be part of the parent carbon chain. So I can say, I can choose the parent carbon chain like this, because I should include the double bond also. So this is my parent carbon chain. Okay, now we should number it in such a way that the functional group should get the lowest possible number. So this should be 1, this should be 2, this should be 3, this should be 4, this should be 5, and this should be 6. Correct. Now next thing, 6 carbon atoms are there, so we know this is hex, word root is hex, and there is no primary prefix, secondary prefix is there, substituents are present at position 4. That is a one open-ended one, so that is 4 methyl. So I can say 4 hyphen capital M methyl. Okay, hex. Then we can say at fourth position double bond, and we know next one primary suffix is there. So suffix means at fourth position you have the double bond is there. So I can say hex 4n, correct? And the secondary suffix is there because functional group is there at position 2. So hex 2, hexen 2. Then you know what is the suffix used when OH group behaves like a functional group, all. So we will put 2 all. So the name is 4-methyl hex 4n 2 all. That is the IUPAC name of this compound. Now the next example is my favorite example. It looks more or like a house, right? House with chimney. Okay. Now, very important one, when I give this to my classroom students, usually they say, sir, 2 carbonyl group and 4 OH group is there. I understood. It's not like that. I have told you in the hint, this is carbon, C double bond O, OH. So this as a whole is a carboxylic acid group, and this as a whole is a carboxylic acid group. Understood? So if you see, this is now my parent carbon chain should be which one then? It should be this one. Correct? So if 2 carboxylic acids are there, then the 2 OH group should behave like what? It should behave like a substituent. So I can start it from here or here because it is a symmetrical compound. In from anywhere you start, you will get the same name. So I will put it from here 1, this is 2, this is 3, and this is 4. So I can say 4 carbon atoms are there, so it should be bute. Correct? Word root should be bute. And prefix. secondary prefix substituents are there at position 2 and 3. So tell me 2 and 3, what is the substituent name? Whenever OH behaves like a substituent, we use the term prefix hydroxy. So I know that 2 comma 3, since both are the same, 2 comma 3 hyphen dihydroxy. Why I am using the term di? Because both two OH groups are there. So 2 comma 3 dihydroxy, word root bute. Then how these are linked? All are linked by single bond only. So butane, all are linked by single bond. So we write butane. We are not putting E because there is what is present, secondary suffix is there. So butane at what position? 1 comma 4. So we will write hyphen 1 comma 4. Then again hyphen oic acid, but two COOH is there. So we use the term dioic acid. So it should be dioic acid. Super, right? So 2 comma 3 dihydroxy butane 1 comma 4 dioic acid is the IUPAC name of this one. Please analyze it, very easy. Word root is this one, then primary suffix all are linked by single bond, so we write ANE. Since secondary suffix is there, E is removed, then its position we noted 1 and 4, so 1 comma 4. Numbers should be separated from alphabets using hyphen, 1 comma 4 hyphen oic acid. Both two are there, so we use the term dioic acid, and we know secondary prefix is there. So 2 and 3 there is substituents are there. So 2 comma 3 hyphen dihydroxy. It's easy actually. Even with the options you can easily, if you know the concept from options, you can easily find out the answer. There will be very little bit difference only. So from the questions you can get the answer. Okay. So I hope you understood this one. So we will go to the next examples. Okay. Hi. So let's see the new question. So it looks more like a virus, right? Okay, so how to do this actually? So if you see here, there is no functional group present here. Multiple bonds are there at this position and this position. So we should choose the parent chain in such a way that the maximum number of multiple bonds should be included. So let me choose it like this. So this is included, and I am choosing it like this. So this multiple bond is included, and this is also. So this should be my parent carbon chain. Now numbering, you know that this is also a symmetrical compound. So if I do it from here or here, you will get the same numbering. So let's say here 1, 2, 3, 4. Okay, this is one carbon, this is another carbon. Okay, 5, and this is 6. Okay. Now how to put the name? You know that 6 carbons are there. So the word root is hex. And there is no primary prefix. Secondary prefix is there at position 3 and 4. You can see two carbon compound is connected here also, here also. So this is 2 carbon means it is ethyl. So at 3 and 4 you have ethyl. So I can start with 3 comma 4 hyphen diethyl. Correct? Diethyl hex. And if you see at position 2 and at position 4 double bond is there, that is a minimum number. So hex 2 comma 4, since both are double bond I am putting 2 comma 4 hyphen diene. So 3 comma 4 diethyl hex hyphen 2 comma 4 diene. Okay, so this is the way you need to name it. Now we will go to the next compound here. So there's, you could see a new representation. Instead of opponent they have kept here Me. This is another representation only. Don't get feared out of this. This is methyl group, nothing else, no difference. So we say this is methyl group, and there is no functional group present here. There is one double bond that you could see here. So we will choose the path in such a way that we should include this double bond. So what should be my path? Longest possible path. So I can say, so I will start it from here. This should be included. So here you could see I have included like this. Now 1, 2, 3, 4, 5. Now I can go in this way or this way. So I know that 1, 2, 3, 4, 5, 6, 7 only. 5, 6, 7, 8. Now 5, 6, 7, 8, 9, 10 if I go in this way. So I will choose that as my path. Okay. So this is my longest path that is possible. Understood? Very, very important. Now how to number it? So if I do the numbering from here, 1, 2, 3, 4, 5, 6, 7 is the number coming for the double bond. We know that when there is no functional group, double bond should get the maximum priority. That means the minimum number. So 1, 2, 3. If you go by this way, 3 is the number. So that is good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, priority is first multiple bond, then only substituent comes. That's why I am giving the least possible number to the multiple bonds. You remember the priority order: functional group greater than multiple bonds, greater than number of carbon atoms, then greater than substituents. Okay, so tell me how to do this. The parent carbon chain has 10 carbon atoms. Super. Then it is deck is coming into picture. Deck. 10 carbon atoms means deck. Now there is no primary prefix because no, it's not a cyclo compound, and primary, now secondary prefix is there. There is substituents there at 5th, 6th, 7th position. 5th position you can see 2 carbon atoms, so it is ethyl. So this is methyl, this is CH3 with this is CH2. This is also ethyl, so 2 ethyl and 1 methyl is present. So by alphabetical order, first we should write ethyl. So we say 5, 6 hyphen diethyl. Okay, 5, 6 hyphen diethyl, then hyphen 7 hyphen methyl. Correct? Methyl, then word root deck. Now how these are linked, actually there is a double bond at position number 3, so I can write deck hyphen 3 hyphen, what is there now, functional group, so it should be hyphen ene. So this should be the name of the compound. So I hope you understood. If you have any doubt, get back to us. Hi, so next we are going to see last examples. Okay, we'll see more examples, of course. Okay, so the first compound. So in the first compound I could see a functional group, that is nothing but my carbonyl group is there. Okay, so I should include this carbon in my parent carbon chain, and there is a double bond, so I should include that double bond also. So the only way I can do that is I can choose my parent carbon chain like this. Okay, so this looks the longest one, not the longest one, which includes almost everything. Functional group carbon atom is included and double bond is also included. Okay, now numbering, as you know, functional group should get the minimum number, so it should be 1, and this should be 2, this should be 3, this should be 4, this should be 5, and this should be 6, and this should be 7. Correct? So at third position you can see 2 carbon atom compounds, it's an ethyl. Fourth position you have a methyl. Fifth position you have a methyl. Okay, so how will you put the word root? 7 is there, so we use the term hept. No primary prefix, it's not a cyclo compound. Secondary prefix, it is there, substituents are there. So 4 and 5 you have a methyl group, and third position you have an ethyl group. So we know that E comes first. Many students here have a doubt, sir, at 4 and 5 2 methyl groups, so we said dimethyl, so D is coming first before E, right? Please remember, di, tri, tetra, those things are not considered for alphabetical comparison. Please remember, pivotal point, very important point. Okay, so at third position you have ethyl group, so we will start with the 3 hyphen ethyl. Okay, 3 ethyl, then hyphen, I know 4,5. Okay, 4,5, what should I write? 4,5 hyphen dimethyl. 4,5 dimethyl, that's I have written. Now word root hept. Okay, now how these are linked? These are linked at fifth position by a double bond, so I will write hept 5n. Now is there any functional group? Yes, functional group is present at position 2, so I will write hept 5n, then 2. Tell me what is the suffix used when carbonyl group comes? On. So this is the name. 3 ethyl, 4,5 dimethyl, hept 5n, 2 on. This is the IUPAC name. Now similarly, can you tell me the name of this compound? So I will write it with another color for your identification. So starting with this one, there is a functional group is present here. So this carbon atom should be part of the parent chain, that is understood. So we have, so we can say 1, 2, 3, then double bond is there, so this should also be part of the parent chain. So I can say, I will choose like this. Okay. Now many students will ask, sir, why do you go like this? Why can't you go like this? Because this is a double bond. Both carbon atoms should be part of the parent chain. That is the rule says. If there is a double bond, you should be including in the parent carbon chain. Functional group carbon is included. The next priority goes to multiple bonds. That's the reason why we are choosing the parent carbon chain like this. Now numbering, again it is easy. So functional group is there, that should get the lowest priority. So this should be 1 and this should be 2, this should be 3, this should be 4 and this should be 5 and this should be 6. Correct. Now substituents, at 5th position you can see ethyl group is present. At 4th position chloro is present. 3rd position there is an ethyl group present. Now chloro and ethyl, who comes first in alphabetical? Chloro. So I can start with saying 4 hyphen chloro, correct? 4 chloro hyphen then 5 and 3. So I say 5 comma 3, okay, hyphen diethyl. So tell me the word root. Hex, okay. Then at 5th position you can see the double bond. So hex hyphen 5 hyphen N. Now it's not finished. There is a functional group OH at position 2. So 5N2 hyphen ol. So this should be the name. 4 chloro, correct? Alphabetically chloro will come first. So 4 chloro, then 5 comma 3. I told always 5 comma 3 same means you should put diethyl. 6 carbon atoms in the parent carbon chain. So hex, at 5th position there is a double bond. So hex 5N. Then at secondary suffix, a functional group is there, that at position 2. So hex 5N2 ol. So this is the way you need to name it. I hope you understood. So we will try out more examples with the different classes. Until now I have touched only with the hydrocarbon some functional groups. We have different types of functional groups. We will discuss one by one. Okay. So please be patient. Some students say, sir, with each chapter we will learn. No, I will not accept that. Please learn that initially, so that whenever you learn any new chapter, it becomes easy for you. The naming should be in our fingertips. Then only organic chemistry is everything for you. Otherwise organic chemistry is zero. Okay, thank you. Hi students. So this is just a correction thing. So I made a little mistake here. If you have understood, please note it down. Here 5th position and 3rd position ethyl group is there. So can I write 5 comma 3 diethyl or 3 comma 5? Please remember, whenever similar functional groups are there, the numbers should be written in increasing order. Okay, I forgot that. So this should be not 5 comma 3, it should be 3 comma 5. Okay, suppose at 3rd position, 5th position, 7th position ethyl group is there, then it should be 3 comma 5 comma 7 triethyl. It should be like that. It should not be the other way. It should be increasing order. Okay, thank you. Hi dear students. So next we are going to learn the IUPAC nomenclature of cyclic organic compounds. Until now we were discussing linear organic compounds. Now we are going to discuss the nomenclature of cyclic organic compounds. Okay. So here so we are going to the rule 1. Okay. Rule 1 states that IUPAC names of cyclic compounds are given by prefixing cyclo before their parent name. So we already know this. Cyclo is what actually? It is 1 degree prefix, correct? So we know that before the word root we need to add 1 degree prefix, that is cyclo. So that they have given directly as a rule. Okay. So let's see some examples. So let us take this one. Okay. I hope you could see. So what is this compound? It looks like a house, right? So cyclic compound means there will not be any gaps. It will be like a circle. It will be starting. There will be no start, and it will be like continuous in nature. Okay, it's like a cycle. Okay. Now how to name this compound? Again the same rule. So here 1, 2, 3, 4, 5. So 5 carbon atoms are there in the parent ring. Okay. So we say the word root is pent. Correct. Now we know that all these are linked through single bonds. So that means the 1 degree suffix is what actually? Ane. Now there is no functional groups present, so there is no 2 degree suffix, and 1 degree prefix is applicable since it is a cyclic compound. So what is the 1 degree prefix you need to add? Cyclo. So you add cyclo. Now there is no 2 degree prefix since there is no substituents, so the name is cyclopentane. So similarly I could give you another example. These are very easy examples. So just to tell me what is the name of this compound. So again you could see 3 carbon atoms are present. So the word root is what actually? Prop. Okay, and all these are linked through what actually? Single bond. So I can say it is ane, correct? Since it is a cyclic compound, I should add the 1 degree prefix cyclo. So this becomes cyclopropane. Understood? So similarly I can draw cyclobutane, cyclohexane and cycloheptane. Any number of structures I can draw. Let me say one more structure I will draw. Okay, last example. Okay, so here you could see a cyclic compound. There is a double bond present. So whenever there is a double bond present, we know that we should do the numbering actually. So numbering, the double bond should get the least number. So 1 2 3 4. So tell me, there are 4 carbon atoms, so it should be but, correct? And you know that there is a double bond at position number 1, so I can say but 1ene. Since it is a cyclic compound, I can add the prefix cyclo. So this will become what? Cyclobut-1ene. So this is the way you need to number it and name the compound. Now we will go to the next rule. Okay, so we will go to the next rule. Okay, so the rule says that if 2 substituents are present at symmetrical position, okay, in cyclic compounds, then follow alphabetical order. Okay, I will explain this. Please listen to it. This is very important. Okay, now I have a compound given here. Okay, so I know that there are no functional groups present in this organic compound, but there are substituents present. There is no multiple bonds are also present in this organic compound, but substituents are present. Now the question here is, I know this is my parent ring. Okay, this is my parent ring. Now question here is, how should I number it actually? So you know that substituents should get the lowest priority, correct? So always I should choose any one of these substituent with the lowest number. So here comes a confusion basically. So let's start with, let's assume I am giving 1 to the chlorine. Now I do it like this: 1 2 3 4 5. Now tell me, what is the locant set? Chlorine is having, okay, listen, chlorine is having 1 and bromine is having 4, correct? Now another person doing this in another way. Let's see how he does. So he given 1 for chlorine and 2 for this one, then 3 4 5. Okay, so 4 is given for this one. So tell me, what is the locant set? For chlorine it is 1 and for bromine it is 3 actually. Okay, now there is a third person who came, and for him he done something like this. Okay, he given 1 here, 2 here, 3 here, 4 here, 5 here. Now again I am looking at the locant set. This becomes 1, 3. Now tell me which one you will prefer. So I know that all of these are starting with 1. So I cannot, with the first digit I cannot decide actually. So I will go to the next one. So the next digit, if I am going, I could see 4 here, here it is 3, here it is 3. So this is discarded because this is biggest number compared to the other 2. Now the biggest question here is, both of them are 1 3 1 3. That means this is symmetrical. So the condition of symmetrical position is coming into picture. Both are 1 3. Now what they are saying, if such a condition is existing, you should follow what actually? Alphabetical order. So tell me, this I have arranged with respect to giving chlorine as 1. Now here this one I am given with respect to bromine. So who comes first, bromine or chlorine? We know alphabetically B comes first, then only C. So bromine should get number 1, then 2, then 3. So this is the correct numbering. Now how you will now name the compound? I know that word root is pent, since 5-membered ring. And I know that all of these are linked through single bond, so it should be ane. That is also correct. Now I know that this is a cyclic compound, so there will be 1 degree prefix, so cyclo will be there. Okay. Now I know that 2 degree prefix will also be there since substituents are there. So I know that at first position bromo, so I can say 1 bromo then 3 chloro, correct? So I can write 1 hyphen bromo, correct, hyphen 3 hyphen chloro, 3 chloro cyclopentane. This should be the IUPAC name of this compound. I hope you understood the condition of symmetry. That is very important. Symmetrical position, though, don't get confused. This is very important. Only by numbering we could say whether it is symmetry or not. Okay, now next one, going to this compound, how will you number it? Again, I know it's a 6-membered ring. There is no functional group, there is no multiple bonds, nothing is there, but substituents are there. So CH3, one free end means CH3, and 2 carbon means it is ethyl group. These two are present. Now the next question here is, we can directly follow alphabetical order whenever 2 substituents are there. So methyl and ethyl, who is coming first? Ethyl is coming first, right? So this will also follow the symmetrical condition. If you have doubt, you can put the numbers and look into it, because both are at almost the same. I can number it and show you. So let me say I number it from here, because I know that ethyl will get the preference. 1, 2, 3, 4, 5, 6. Now if I do it in the other way, 1, 2, 3, again 1, 3, 1, 3, symmetrical position. Now how I will name the compound? Tell me. 1 ethyl, 3 methyl. So I will start with 1 ethyl, then hyphen 3 methyl cyclo, 6-membered ring, so it should be hex. All are linked through single bond, it should be ane. So this should be the name of the compound, 1 ethyl, 3 methyl cyclohexane. I hope you understood. If you have any doubt, please let me know. Okay, very important, understanding the symmetrical position. Okay, now coming to the rule number 3. If more than 2 substituents, okay, if more than 2 substituents are present at unsymmetrical position, then numbering should be done according to lock and rule. We have already learned what is lock and rule. We will write down the sets and we will see which is the first numbering. Okay, that is, it is also called what? First point of difference rule. So it is stating that if more than 2 substituents are present in your cyclic compound, that they are at unsymmetrical position, in that case the numbering should be done according to what rule? Lock and rule, or it is also called first point of difference rule. So let's see how it is actually. Now an example is given here, so we need to name this compound. Now I know that this is an open point, so this should be methyl group. Methyl, iodide and ethyl is present. So how will you number it? I will show you the different ways of numbering and I will help you how to understand this. So let's say I have started from numbering here. So 1, 2, 3, 4, 5, 6. Now tell me what are the position of the substituent. Now I know that 1 is there, so 1, then 3 and 4. So 1, 3, 4. Okay, this is one way I have done. Now another person is doing it in the other way. Let's see how it is. Okay, so I will write down all possibilities and you can decide which one is correct. Okay, so another person has done it like 1, 2, 3, 4, 5, 6. Now tell me the locant. Here it is 1, then it is 4, then it is 5. So I can write 1, 4, 5, correct? Now with this as the least highest priority, I have written both possibilities. Now I will go to the next substituent, that is this one. So I will start from here 1, 2, 3, 4, 5, 6. Now tell me the locant. 1, 3 and 6. So I can write 1, 3, 6. Correct? Now I am going to write the next possibility. Let's see. So next possibility 1 here itself, but I am going in this way. 1, 2, 3, 4, 5, 6. Now tell me the locant. 1 is there, then 2 is there, then 5. So I can write it is 1, 2, 5. Now that is completed. So I will go with the third substituent. Then I will write the possibilities. Okay. So third substituent is this one. 1, 2, 3, 4, 5, 6. So tell me what is the locant. That is 1, 4, then 6. 1, 4, 6. Correct? Now the last possibility I am going to write. So 1, 2, 3, 4, 5, 6. So it is 1, 2, then 4. So 1, 2, 4. Now tell me, how will you decide which is the correct numbering here? Now I will go to first one. Everything is 1, 1, 1, 1, 1, 1. So with the first locant I cannot find which is the correct numbering. Now we will go to the next locant. So here it is 3, here it is 4. So I can eliminate this. This is the least number. Here also it is 3. Here it is 2. Super. Then I can eliminate all these. Now 1, 2, 5. Here also it is 4. That is greater number. So only 2 options are left behind. 1, 2, 5 and 1, 2, 4. Now with this second locant I cannot find. Now we will go to the third locant. I understood this is 5 and this is 4. So least number is 4 here. So least number is 4. That means this is the correct locant. This is wrong. So 1, 2, 4. That is 1, 2, 4. That is the correct one. Now I can name the compound. Can you tell me the name of the compound here? So I know that there is at first position methyl, second position iodo, fourth position ethyl. So I know that we should start with what actually? Alphabetical order. So when multiple substituents are there, so which one comes first? Iodine I, methyl M, ethyl E. So E comes first. So let me write 4 hyphen ethyl, correct? Hyphen, then M and I, which will come first? You can say alphabets A, B, C, D, E, F, G, H, I, J, K. So I will come. So 2 iodo, then 1 methyl, correct? 1 methyl. We know it is a cyclo compound, so we will write cyclo. 6 carbons are there, so hex. All are linked through single bond. It is hexane. So my answer is 4 ethyl, 2 iodo, 1 methyl cyclohexane. You understood the numbering. That is very important. How you identifying the correct locant set. This if you understood perfectly, then you can do all questions in this one. Okay. So here we will go to the rule number 4. Rule number 4 is a little bit interesting rules. Okay. If multiple bonds are present, okay, then consider those carbons continuously. What does that mean actually? Let's see with this example, then you will understand. So you have an organic compound with the multiple bonds present here. So I need to number this. Since multiple bonds are present, I should give the least possible number to the multiple bond, but both 2 double bonds are present. Okay, so let me start numbering like this. 1, 2, 3, 4, 5, 6. Now tell me what are the least number coming to this multiple bond? 1, correct? And least number between 3 and 4 is 3. So 1, 3 is the locant I am getting. Now suppose another guy done like this. Okay, 1, 2, 3, 4, 5, 6. So tell me the numbering. Here 1 and here 4. So some students will do like this and they will think, sir, on doing this with the locant set I understood this is the correct numbering, and they will go for this. But this is actually wrong. That is what the rule says. Why? Actually this is wrong. Please read the statement. If multiple bonds are present, then consider those carbons continuously. That means if I am giving 1 to this carbon, this is a carbon of the multiple bond, then I should not give 2 to here, because this is a carbon of non-multiple bond. So that is wrong. I should give 2 to the next carbon that is a part of the multiple bond. Okay, suppose if I am giving 1 here, then 2 should be this one, it should not be this one. That is what the rule is saying. So tell me now, what is the name of this compound? So this is the correct one, what I have written here. So 1, and among this lowest one is 4. So what is the name I can give here? Tell me. So let me rub this. Okay, what is the name we can give here? So I can say cyclo. So tell me, cyclo hex, then 1 comma 4, so hyphen 1 comma 4, then hyphen, both are double bond, so I will use diene. So it should be cyclohex 1 comma 4 diene. Understood? Very important rule. So next one, how to do it? Listen. So functional group and double bond, who should be given priority? We know that it is a non-carbon functional group. So the carbon which is connected to this functional group should be part of the parent chain. That is correct. Now I know that while numbering, this should get the lowest priority. So 1 here, I can go like this, 2, 3, 4 will come here. But if I go like this, 1, 2, 3 will come here. So I will prefer this numbering, 5, 6. So how to name the compound? Tell me. Cyclohex 3n, cyclohex 3n 1 all. You know that 1 degree prefix is added, 2 degree prefix, it is not applicable, there is no substituent. Word root 6 carbon atom hex is added, then 1 degree suffix at third position double bond, so 3n, then 2 degree suffix is there at what first position, all is there. So this is how you do the numbering. So please remember, whenever double bond is present, you should take them continuously, 3, 4. Understood? Here also I have done like that, here also it is done like that. So please remember this rule. This is a very good rule. Most of the students may create mistakes because of not knowing this rule. Okay, so we are coming to the last rule. I may say this is the golden rule. They can ask you this rule or questions related to this rule for the NEET exam. Very, very important. Okay, so just I will read the rule. If number of carbon in the ring is greater than or equal to the number of carbon in the side chain, then the parent name should be made according to the ring. Okay, we will see what it is actually. Listen here. Now I have taken an example here. So you can see here this is the ring part, correct? And you could see a substituent also here. Okay, now the question coming here is, sir, think like you have a ring that is made up of 4 carbon atom and you have a side chain that is made up of bigger length. In that case, will you give priority to the ring chain compound or the linear compound? It's a bigger question at that point of time. So they have made a rule, very simple. You need to count the carbon atoms in the ring. So I know that there is 1, there is 2, there is 3 and there is 4. So I can say there is 4 carbon atoms are there in the ring. And similarly, I will count the number of carbon atoms in the side chain. So here a question comes, sir, whether this carbon will be considered for the ring or for the side chain. So during counting, you can consider that for both, for the ring as well as the side chain. Now for the ring, I have taken this and there is 4, I have found it. For the side chain also, I am taking this 1, 2, 3, 4. Now ring has 4 as well as the side chain has 4. Now what is the rule saying? If the number of carbon in the ring is greater than or equal to the number of carbon in the side chain, then the parent name should be made according to the ring. That means we should consider the parent as the ring. So how will you number it? If parent is the ring or the parent chain is the ring, then this should be the substituent. So I can say again, if substituents are attached to the ring, there is no functional group or there is no double bond. So substituent should get the lowest possible number, 1, 2, 3, 4. Correct? So now how I will say 1 hyphen, how many carbon atoms are there? 1, 2, 3. 3 carbon atoms are there because this we are already considering as part of the parent chain, this carbon atom. So remaining 1, 2, 3. So 3 carbon atoms means what actually it is? Propyl, correct? So I can say 1 propyl cyclo, so we say cyclo. Please remember this is a small letter because this is coming in between. 1 propyl cyclo, word root is bute, all are connected through single bond, so it should be 1 propyl cyclobutane. Okay, easy to understand, right? Now we will come to the next example that is quite a little bit more interesting. Now we will again count, there is a side chain, so we will count here 1 2 3 4 carbon atoms are there. Now we look into the side chain 1 2 3 4 5 6. So 6 carbon atoms are there. So surely 6 carbon atom means here the parent should be what? It is not the ring, it is the side chain is the parent. Then this ring is the substituent in this case. So I may say I will mark the parent, continuous parent carbon chain. Okay. So this is my continuous parent carbon chain. Into that there is a substituent. So in the continuous parent carbon chain, if there is a substituent is there, that should get the lowest possible number. There is no multiple bond, functional group or anything is not present. So I will put 1 here, correct? To the first carbon there is a substituent added. This is 2, this is 3, this is 4 and this is 5. So please remember the common carbon atom between this one is always given to the ring. Okay. So how you say this one? 1 cyclobutyl. So I can write 1 hyphen cyclobutyl, correct? Butyl. How many carbon atoms are there in the parent chain? 5. So my word root is pent and they are connected through single bond, so it should be 8. So answer is 1 cyclobutyl pentane. Understood? So we will see more examples, don't worry. So this is a very important rule, please remember this. Hi dear students, so yesterday we were discussing the IUPAC rules for the nomenclature of cyclic organic compounds. So today we will start doing some problems based on the cyclic organic compounds concept. Okay, so you have the first question in front of you. Okay, so whenever you are given a cyclic compound, what is the thing you need to do? You need to identify the number of carbons. So 1 2 3 4 5 6, correct? 7 8 9 10 11 12. So the parent cyclic compound has 12 carbon. So 12 carbon means what is the word root? Dodec, correct? Dodec. And we know that all are linked by single bond. So what is the primary suffix you can add? "ane", correct? Now we know that it is a cyclic compound. So there is 1 degree prefix you can add. What is the 1 degree prefix? That is cyclo. And there is no 2 degree prefix since there is no substituent. So what is the IUPAC name? Cyclododecane. Understood? So very simple. So similarly, if it is 11 carbon means undec. Okay, 10 means dec, 9 means non, non, 8 means oct, 7 means hept, 6 means hex, 5 means pent, 4 means but, 3 means prop, 2 means eth, 1 means meth. Okay, that we have already discussed. Now we will go to the next example, example 2. So here you are given a cyclic compound and please believe that there is a functional group that is present outside the cyclic compound. Okay, so we know that whenever functional group is attached to some carbon atom in the cyclic ring, that carbon should get the highest priority. That means the lowest number while you numbering it, correct? So I should mandatorily mark this as number 1. Then I can go either in clockwise or anti-clockwise because this is lying exactly opposite to this. So 1 2 3 4 5 6, correct? And you know that whenever there is only 2 substituents, okay, but here one is a functional group and other is a substituent. So we know that what should be there? First one, primary, secondary prefix substituent is there. So I can start with, tell me, 4 hyphen bromo, correct? 4 bromo. Then I know that it is a cyclic compound, so the prefix should be cyclo, should be there. 4 bromo cyclo. Now the word root, 6 carbons are present, so I can use the word root hex, hex, correct, and all the 6 carbon atoms are linked by single bond, so I can use the term hexane, but you know that there is 2 degree suffix is also there, so E is removed, and the position number 1 you have the OH group, so its suffix used is whenever it acts as a functional group it should be ol. So I got the answer 4-bromo cyclohexane 1-ol. So that is the answer. Okay, so we will go and discuss the next question. Hi students, these 2 questions are very important actually. So we will go to the first question. Listen here. Now I have a ring as well as there is a side chain here and there is one side chain here. Now I know that when I number the ring or when I count the ring, I understood that this is a 4-membered, so 4 carbon ring, correct? And whenever I am looking at the side chain, I understood that it is 1, 2, 3, 4, 5, 6. So that is a 6-membered side chain and 4-membered ring. So we know that whenever the side chain has a greater length, okay, then that should be considered as my parent carbon chain. So this is my parent carbon chain. Very, very important. Last rule. Please go through that. So this is my parent carbon chain. So that means that there is no other functional group or anything is present in the parent carbon chain, only substituent is present, so that should get the lowest priority. So I will give this as number 1 carbon, and this is number 2, this is number 3, and this is number 4, and this is number 5. Now I know that in the first carbon there is a substituent, that substituent is this one, correct? Okay, now and in this substituent there is another substituent, so we need to do another numbering. Whenever there is a substituent and inside that substituent there is another substituent, we need to do another numbering inside that substituent. So please listen, that's why this question is important. So whenever you have given 1 to this carbon atom, so 1 to this carbon atom and it is connected through this particular carbon, so whenever you are doing numbering inside the substituent, this carbon atom should get the minimum number. Why means because this is the carbon that is connected to what? Principal carbon chain. So that should get the lowest number. Please remember this point, very, very, very important. Okay, now what should be, then I can go in this way, 1, 2, 3, 4, then 4 will be the number that will be given to the substituent. I can also go in this way, then 2 will be the number. So I know that there is no functional group or multiple bond, then substituent will get the priority. So again I should choose the lowest number. So 1, 2, 3, 4, correct? So now how to start with? So I know that my word root is again 5 carbon atoms, so there should be pent, correct, and all are linked by single bond, so there should be ane because there is nothing else. Now coming back to primary suffix, so primary prefix, what should be present? There is no primary prefix applicable because the parent chain is not a cyclo compound, only the substituent is the cyclo compound, so there is no primary prefix applicable here. Now I need to apply the secondary prefix, that is the substituent. So substituent is present at the position 1, so I can say 1, correct, hyphen. Now how I will do this complex substituent? I need to say inside this 2-methyl, this is which one? Cyclobutyl. This is 2-methyl, then cyclobutyl, 1 H is replaced since it is a substituent. So I write 1-2-methyl, okay, 2-methyl cyclobutyl. So 1 hyphen, please understand, 1 connected to here, so that's why 1 hyphen. Then inside this at 2th position we have methyl, so 2-methyl. The whole thing is cyclobutyl. Then we have the parent chain, that is pentane. Understood? So this like naming they can ask. So please understand, it's very easy, nothing else. First you identify the parent chain, then put the word root and put the suffix. Then substituent, if it is a complex substituent, that means inside the substituent there is another substitution. In that case you need to put another numbering in such a way that if there is functional group, that should get the highest priority. If it is multiple bond, then the next priority, then comes the substituent. So 1, 2, so 1, this is 1, this one, first in the first carbon atom the substituent is present, that's why 1 hyphen. Then inside this one there is at second position there is a methyl group, so 2-methyl cyclo, then butyl pentane. Understood? Now coming to the next example, very good example. Listen here. If you count the number of carbon atoms, I understood this is 4 carbon atoms. Now when I am looking at the side chain, how many carbon atoms are there? 1, 2, 3, 4. So whenever there is equal number of carbon atoms, the cyclic compound should get the priority. But please listen, whenever there is a functional group or multiple bond, okay, whenever there is a functional group or multiple bond is present, then that wherever the functional group is present, that should be considered as the parent chain. So here functional group is present in the side chain, but the side chain has less, if you say 4 carbon atoms, and this one also has 4 carbon atoms. The rule says, what it is saying, if there is no functional group, both of them has equal number of carbon atoms, means who will get the priority? The cyclic compound. But here the side chain has what? The functional group is present. So in that case, the side chain should be the parent carbon chain. Please remember that. Okay. Now I am choosing this as my parent carbon chain. Okay. Now I need to number it in such a way that the functional group should get the lowest priority. So if I number it from here 1, 2, 3, so 2 is coming. So if I number it from here 1, 2, 3, then also 2 is coming. Now after functional group there is no multiple bond, now substituent is there. Now we need to take care, substituent should get the lowest priority after functional group. So if I go from here, 3 is the number coming for the substituent. But if I go from here, 1 is the number coming for the substituent. In both ways functional group has no impact. So I will choose 1, okay, 2, then 3. Now start doing it. So I know that parent 1, prop, correct, 3 carbon atom. At second position, prop. So all are linked by single bond. So I will write propan, then hyphen. At second position there is an ol, propan 2 ol. Now I will go to the 1 degree prefix. 1 degree prefix is not applicable because the parent carbon chain is a linear chain, and 2 degree prefix is applicable since the substituent is present. So at first position what is present? Cyclobutyl. So I can write 1 hyphen cyclobutyl, 1 hyphen cyclobutyl propan 2 ol. This should be the answer. Understood? So this is now here behaving like a substituent. That is the reason why 1 cyclobutyl is coming. 1 H is replaced by this. So 1 cyclobutyl propan 2 ol. Okay. So we will go to the next examples. Very simple. So you have the next example in front of you. Okay. So here I could see there is a ketone group connected to here. Okay, so we know that when keto group is there, that should get the lowest priority. So it should be 1, 2, 3. So how to name this? The parent chain has 3 carbon atoms. So I will put prop. All are connected with single bond. So I can write propan. And I know in position 1 there is keto group. So its suffix is on. So propan 1 on. And I am going to the other one, that is the 1 degree prefix. I know that cyclo compound, so I will put the term cyclo, and there is no 2 degree prefix, there is no substituent, so the answer should be cyclopropan 1 on. Understood? Now coming to the next example, very very important, please mark this as important. I will tell why it is. So in this question, the main thing is there is a functional group is present, that is cyanide, okay, and the biggest thing is this cyanide is present outside the ring. So many students will ask me a doubt, sir, since the cyanide is present outside, can we treat this as my parent carbon chain? But there is a understanding, like if there is only the functional group, carbon containing functional group, only carbon containing functional group is present, there is nothing extension, CH2CN, nothing is there, only CN is there, then in that case how I can number this? Actually it is not possible. So if you look at the priority table, they might have shown that if cyanide, in cyanide this carbon, if it is included, then we use the suffix nitrile. If carbon is included means what? If carbon is included in the parent carbon chain, then we use the suffix nitrile. But in certain special cases like this, where you cannot include this in the parent carbon chain, and we cannot even make a parent carbon chain from here also, in that case we take this as my parent carbon chain, but without the functional group, without the carbon containing functional group. In that case, if you see, they have told very clearly, we use the term carbonitrile. And the logic behind here, the carbo, is because this carbon is not included in the parent carbon chain. That's the reason why they coined the term carbonitrile. So tell me here, nitrile or carbonitrile should be used. I know that I cannot include carbon here in the parent carbon chain. This is my parent carbon chain. So in that case, I should use what? Carbonitrile. Now tell me, this should get the lowest number 1, 2, 3, 4. So I can say cyclo. There are 4 carbon atoms, so it should be but. All are connected through single bond. I can write cyclobutane. You don't want to remove E because carbo is separately present. So cyclobutane carbonitrile. Very, very important. Similar to this, many things are there. Sometimes they may attach here COOH. In that case also, you can see in the priority table, if that carbon is not included, in that case we don't use oic acid, instead we use carboxylic acid. So the answer will be cyclobutane carboxylic acid. Sometimes they may use CHO. In that case also, you know, if carbon of the CHO is included, then we use the term AL. Instead, otherwise we use the term carbaldehyde. So answer will be cyclobutane carbaldehyde. Understood? This is applicable only if there is only one carbon atom outside. Understood? If 2 carbon atoms are there, then I will combine those 2 carbon atoms and will make that as my parent carbon chain. I will give you the example. So I hope you understood this. Very, very important. So we will go to the next example. Hi students. So in this question, we have seen a similar question in the previous example. So this is also like that. You have a functional group that is present outside, that is also a carbon containing functional group. That is why this much confusion. So a carbon containing functional group, you know that as per the rule, that carbon should be part of the parent chain. But here there is only one carbon, there is nothing else. Another thing is a ring actually. So you cannot include this carbon in the parent carbon chain. So the rule says that if carbon of COOH is included in the parent carbon chain, that is included means in the bracket, then we use the suffix oic acid, correct? Suppose if this is not included, that is it is like COOH not included, in that case we use the term carboxylic acid. So this is the term we use, correct? So in this case, now tell me which one to be used. We cannot include this carbon in this parent carbon chain, that is a ring. So in that case, we should use the term carboxylic acid. So we know how much membered ring is this. 1, 2, 3, 4, 5. It's pent. All are connected through single bond. So it is pentane. And we know there is cyclic compound. So cyclo. So I can say cyclopentane, correct? Cyclopentane carboxylic acid. Okay, understood? Good. Now come to the next question, very important. These two are very, very important. In this case, you can see that COOH is outside the ring, but there is another CH2 group is along with this. So in this case, I can say the parent chain is this one because there are minimum 2 carbon atoms there. So in that case, I can consider this as my parent carbon chain. In this case, that was not possible. That is the reason why we use the term carboxylic acid. Now here, this carbon of the COOH is included in the parent carbon chain. So I should use which one? Oic acid. Correct? Now if this is the parent carbon chain, so I know that while numbering, this should get the lowest possible number and this should be 2. So in the second position, then this will behave like what? It is a substituent. So how I can name this compound? I can say at the second position. So first I will write the secondary prefix, that is 2-cyclohexyl. 2-cyclohexyl. Then I will write what? 2-cyclohexyl. Then there is no 1 degree prefix. Why? Because the parent chain is a linear compound. So word root is 2 are there. So eth. correct? And these two carbon atoms are linked by single bond, so I can say ethane, and 2 degree suffix is there, that is carbo at what position? First position. So ethane 1, we know that we will use the term oic acid. Okay, so the answer is what? 2 cyclohexyl ethane 1 oic acid. Very important. Please see the difference. In this one there is only one carbon atom outside, that is of the functional group. That is the reason why we take this as my parent carbon chain. Okay, here minimum 2 is required, so minimum 2 came, so this becomes the parent carbon chain and this becomes the substituent. Very important question. Okay, so I hope you understood. We will go to the next examples. So we have the next example in front of you. Okay, so here if you see this question, here also you could see, we know that there is a double bond present outside the ring and there is only one carbon atom present here. So my parent should be again here, it should be the ring, because there is only one carbon outside with a double bond. I cannot take that as the parent carbon chain. So many students will ask a doubt here, sir, as you told, if there is a functional group or multiple bond present, whether in the side chain or ring, if it is present in the side chain, then that should be the parent chain, or if it is present in the ring, then the ring should be the parent chain. But here the double bond is present with the side chain, then why you are not taking side chain as a parent? The reason for that is there is only one carbon atom there. There is only one carbon atom, we cannot make that as the parent chain. Okay, so in that case we take this as the parent chain. So what should be the answer here? So we know that what is the substituent here? Methyl. So if CH3 means, we use the term what actually? Methyl, correct? Methyl. If CH2 with 2H replaced, then we use the term methylene, or we use methylidene. Both are correct. Commonly we use methylene. So what should be the answer here? I can say methylene. So at one position, either you can mention that one hyphen methylene, tell me methylene cyclohexane. That should be the answer. Understood? So this you should remember. If it is 1H is replaced, we use the term methyl. 2H is replaced, we use the term what? Methylene. So this is single bond and this is double bond. Methylene, 1-methylene cyclohexane. Okay. Now coming to this one. This one we need to think many things. So double bond is present inside the ring. So surely this is my parent chain. Now the question here is, there is substituents are also there. So double bond and substituents are there. So priority should go to double bond. So double bond should get the minimum possible number. So let me try it. So and we know that whenever you are putting double bond, the numbering in double bond, it should be continuous in nature. I cannot put 1 and 2 here. That is not possible. If I am putting 1 here, 2 should be here. Then 3, 4, 5, 6. So in this case, tell me what are the locants coming. For the double bond, it is 1 and 2. And for the methyl, it is 2. And for the nitro, it is 6. Correct? If I do it in this way. Suppose somebody is doing it in this way. Okay, think like somebody is doing it in this way. Here he is giving 1 here. Can 2 be here? No, it should be continuous. 2 should be here and 3 here, 4, 5, 6. Now put the locant. Locant becomes 1, 3. Now tell me, as per the first point of difference rule, in both cases for double bond 1 and 2 is coming. So next we will look into the substituent, and its locant is 2, 6 and 1, 3. Which is the correct one? The lowest number is this one. So this should be wrong. So this looks the correct numbering. Now tell me the way we can name this compound. So first we will write what? 2 degree prefix. 2 degree prefix. There is 1 methyl and 3 nitro. Who comes first alphabetically? LMN. So methyl should come first. So I can write 1 hyphen methyl, correct? Then hyphen 3 hyphen nitro, correct? So 1 degree prefix is over. Now we will go to, so 2 degree prefix is over. Now we will go to 1 degree prefix. Since it is a cyclic compound, we use the term cyclo, correct? And now tell me the word root, how many are there? 6 carbons are there. So cyclohex, correct? cyclohex, and we know that at first position there is a double bond is there, so I can write cyclohex 1-ene. So this should be my IUPAC name. So I hope please understand the way with which I am framing the name. That is very, very important, and please do it in that way. I hope you understood. Now next we will try to do the naming based on each families. Okay. Hi students, so here we are going into a detailed look on each functional groups and its naming. Okay, so even though I have given you the table, I will go each group wise and we will try to see, because this will give you a fundamental grip on the organic compounds. That's the reason why I am going in depth. So you know that first comes in the priority table. Who comes first in the priority table? That is carboxylic acid. So I have given the heading IUPAC nomenclature of carboxylic acid. So you know that what is the carboxylic acid group? C double bond OH. So that means it has one functional group OH and there is a keto group C double bond O. So combining this will become the carboxylic acid. So its bond line notation is, you could see here, C double bond OH. So this is the bond line notation. Now this is called a carboxyl group. Okay, now what is a suffix? What do you mean by suffix? We know that whenever there is a carboxylic acid group is present in a compound, it has got the highest priority, right? So at that case there is something called second degree suffix is there. So as part of that suffix we used to add one particular term to indicate that it is a carboxylic acid. Such a term is called oic acid. So how will you introduce this oic acid? Listen here, this oic acid is introduced when the carbon of that carboxylic acid group is included in the parent carbon chain. Okay, so how will you do that? A carboxylic acid is named by replacing the terminal E of the alkane. Hope you remember, if it is methane, how we will write methane, then position of the carboxylic acid followed by oic acid. So that is by replacing the terminal E of the alkane name with what? Oic acid. When we will do this, if that carbon is part of the parent carbon chain. There can be other case where carbon cannot be part of the parent carbon chain. We have seen some examples, you remember, I hope. Now next case, if suppose that carbon is not part of the parent carbon chain, exceptional case where I have told you in outside the ring there is only COOH, you cannot form a parent chain there. In that case, since that carbon is not included in the parent chain, we use the term carboxylic acid. That's why it is written if carbon not included in parent chain. Okay, and there can be a special case where this carboxylic acid can behave like a substituent. This most of the students will come and ask me a doubt. Sir, you only told carboxylic acid comes first in the functional group. So whenever carboxylic acid is there, it should be the main functional group. Then how can it behave like a substituent? Very, very good question. I will say a special case, I will come to that. Whenever there are more than one carboxylic acid, so this is where I am going to introduce you the miscellaneous naming rule. I have already told there is some miscellaneous rules are there. I have not taught you. I will teach in this occasion where I can teach you on that particular miscellaneous location. This carboxylic acid also behave like a prefix. When it behaves like a prefix, we use the term carboxy. I will tell that situation. Right now you believe that the prefix used there is carboxy. What is prefix? Whenever the functional group behaves like a substituent, we use the prefix of that corresponding functional group. So for carboxylic acid, the prefix is what? Carboxy. Okay, now we will go to different examples, and also at that point of time I will also explain that miscellaneous rule and the example. Okay. Okay, so now we will try to see the examples that comes under carboxylic acid. So I will start with simple examples, then I will go complex. Okay. So here first acid, you could see here there is only COOH group and one H is there. There is only one carbon atom, so we use the term what? Meth. Correct? Meth. So all they are connected through single bonds, the parent chain, so we use a methane. Then at first only one position the oic acid is there, so methane 1 oic acid. Understood? So we can even say methanoic acid, that is also correct, or you can say methane 1 oic acid, both are correct. Now coming to the next IUPAC name, so we know that carbon containing functional group, so this is my parent chain, correct? So I'll put 1 here, 2 here. How many carbon atoms are there in the parent chain? 2 carbon atoms are there. So we use the term eth, and these are connected through single bond. So ethane, correct? Then first position acid is there. So and that carbon is included in the parent chain. So we use the term ethane 1 oic acid or ethanoic acid. Both are correct. Ethane 1 oic acid. Okay. So this is also called ethanoic acid. Whenever 1 is there, you don't want to keep that specifically. You can remove that also. But that is the correct way basically. So in exams it depends. So you can even remove that one. You can say methanoic acid and this is ethanoic acid. Both are correct. Now coming to the next one here. So here COOH functional group is present. So whenever I start numbering, this should be my parent first number. Minimum number should go to the senior most functional group, even though ether is present here. OCH3, it's an ether linkage, O linkage, OC linkage, ether linkage. Now 1, 2, so you know that whenever multiple functional groups are present, the one which is senior most will behave like what? The functional group, and the other one will behave like what? Substituent. So here ether is a substituent. So I can say 1, 2, 3, 4. Correct? So tell me, what is the whenever ether behaves like a substituent, what is the prefix used? You can go into the table and see that is alkoxy. Alk determines the type of alkane that is connected. So here you know that one carbon, only one CH3 is there. One carbon means it is meth. So alkoxy. So alk I am replacing by meth. Then it becomes methoxy. So I know that what is the substituent here? 2-methoxy. So I can say first I will write the 2 degree prefix, that is 2-methoxy. Correct? 2-methoxy. How many carbon atoms are there in the parent chain? 4 carbon atoms. So I can say bute, 2-methoxy, bute. All are connected through single bond. So I can say butane. Then first position there is oic acid. So I can say 2-methoxy, 2-methoxy, butane 1 oic acid. Understood? So please remember, whenever there is multiple functional groups, only one will behave like the actual functional group and other will behave like a substituent. This information we are getting from the priority table. At that point of time, the senior most functional group's suffix is used, and the one which behaves like a substituent, its prefix is used. So for ether linkage, the prefix is alkoxy. Since there is only one carbon atom, we use the term methoxy. Suppose if it is CH2 CH3, that means 2 carbon atom, then it becomes eth, then we write ethoxy. Understood? Now coming to this one. So here COOH is directly linked with the benzene. So whenever there is a benzene comes, it is a special case. We will teach the benzene as a separate stuff. So we can say this is called benzoic acid. This is widely accepted name. Benzoic acid. So many students here used to say me one thing, sir, whether it is correct, sir, here COOH is outside your ring, so and that carbon is not included here, so can I say oic acid here? So the more correct should be like benzene carboxylic acid. Whether this is more correct? Many students used to say this. So this is more correct, this is less correct, because this was invented way back. So at that point of time, benzoic acid is a widely accepted name. So now also it is widely accepted. So that's the reason some people used to say benzoic acid also. But the more correct name is benzene carboxylic acid. What is the logic behind that? Because this carbon is not included in the parent chain. In that case, we use the term carboxylic acid. Understood? So these are the two names possible. Suppose in exam they give both, means you give preference to benzene carboxylic acid. Okay. Now the next one, it is represented as a bond denotation. Now you know that this is a carbon, so C double bond O OH. This is also carbon, C double bond O OH. So its structure looks like this, which is written as like this. Correct? 2 carbon atoms linked through single bond and C double bond O OH, C double bond O OH. So what is its name? Common name is very famous. Its common name is oxalic acid. Please remember, its common name is oxalic acid. Its common name is oxalic acid. What is its IUPAC name? How we can name it? So if I give number to here 1, 2, only 2 carbon atoms are there. There is no other way. So whenever two carbon atoms and two COOH is there, I can use the term dioic acid. Correct. So tell me, two carbon atoms means I use the term eth, and they are linked through single bond, so I can use ethane. Correct. So ethane, and at what positions it is there? 1 and 2. So I can use 1, 2 hyphen dioic acid. Okay. So this is more correct. Ethane 1,2 dioic acid is correct, and sometimes they use the term this also, ethane. Okay, ethane dioic acid. Dioic acid. This is also widely accepted. So more correct is this one, ethane 1,2 dioic acid. Okay, this is also correct, ethane dioic acid. Okay, now comes to the third one, and this is also a famous acid. Its common name is malonic acid. MALONIC, malonic acid. Please remember, sometimes they will ask. Malonic acid is a common name. So how will you name this compound? Here also COOH, here also COOH, and 3 carbon atoms are there. So if I number it from any way, it remains the same. So 1, 2, 3. Now tell me, how many carbon atoms are there? 3 carbon atoms. So the term should be what actually? Prop. They are connected by single bond. So propan 1,3 dioic acid. Correct. Propan 1,3 dioic acid, or sometimes they use the term propane dioic acid. Sometimes they use it like this also. Both are correct. Understood? So I hope you understood. Please go through it, and if there is any doubt, tell me. Here, if you need, you can draw the picture of this like this one also. Very simple. What is the thing? ACH2 will come in between. That's it. Okay. So I hope this is clear. Now we will go to the next examples. So I have told you that there are some special cases or special rules are there. So I am coming to that. The special rule states that if a carbon containing functional group, okay, if more than 2, very important, please listen the term, if more than 2 carbon containing functional group is part of the parent carbon chain, in that case not even a single carbon of that functional group is included in the parent chain. I hope you didn't understand. I will write it out. So the rule says that, listen here, if a carbon containing functional group, what are the carbon containing functional group? Carboxylic acid COOH, cyanide CN, then CHO aldehyde. These are carbon containing functional groups. So if this is part of the parent chain, so if you see here, how many are there? There is one, there is another one, there is another one. So it states that if there are more than 2 carbon containing functional groups are present in the parent chain, then none of the carbon of that functional groups are included in the parent chain. That means you can choose the parent chain like this only. I have not included this C and this C. The reason for that is there are more than 2 similar groups, carbon containing functional groups, more than 2 carbon containing functional groups are present in the parent chain. So I have chosen, then in that case what should I do? I should not include any carbon of that functional group. This is the special rule or miscellaneous rule. Okay, so in this case I can say, so I will write that rule. If more than 2 carbon containing functional groups are part of the parent chain, then none of the carbon of the functional group are included are included, none of the carbon of the functional group are included in the parent chain. Correct? This is what we have done. So this is the special rule. Okay. So here another specialty is there. This compound is called citric acid, and you know that this is present in fruits like lemon, and it's a rich source of vitamin C. Correct? So sometimes they will give this structure and ask you the common name. Common name is citric acid. So how will you put the IUPAC name? So I have told the rule. So I have not included this carbon, I have not included this carbon, and I have not included this carbon. Now this is my parent chain. Now you know that whenever carbon of a functional group is not included, then what is the suffix we are using? Carboxylic acid. So I can number it. If I number it from here or here, it is similar because all the three has COOH. So 1, 2 and 3. So I can say the 3 carbon means I will use the term prop. All are connected through single term. I will use propane. So please remember, whenever you are using the term suffix carboxylic acid, E should not be removed. E should not be removed. E should not be removed whenever you are using the suffix carboxylic acid. So propane hyphen, what is the position? 1, 2, 3 hyphen, how many are there? 3 are there. So we use the term tricarboxylic acid. Tricarboxylic acid. Whether the naming is complete? No, because at the second position there is a OH group. In this case, OH group behaves like a substituent. If OH groups behave like a substituent, its prefix used is what? Hydroxy. So I can say, I will use this as a small letter then. So what is my 2 degree prefix? I can say 2 hyphen hydroxy 2-hydroxy propane 1, 2, 3 tricarboxylic acid. So this is the IUPAC name of citric acid. Please remember, very, very, very important. Okay. So we will see the next example. Okay. So here also I am giving you another important acid, that is its common name is malic acid. Similar to citric acid, it is also found in lemons, apples and grapes. So next question is, how will you give the IUPAC name? Again, please concentrate on the question. Now if you see this as the parent chain, there is only 2 COOH groups connected. So please remember, our special rule is applicable if more than 2 carbon containing functional groups are present, then only apply the special rule. What was the special rule? You should not include carbon of that functional group in the parent chain. So here only 2 is there. Then think about OH. OH does not contain any carbon. So OH is a non-carbon functional group. So don't worry about that. Okay. And we know that whenever COOH is there, OH will behave like a substituent. Correct. So in this case, the wonderful thing is this carbon should be part of the parent chain. Normal rule. Why? Because it has only 2 COOH. Whenever more than 2 is present, then only the special rule will come into effect. Okay. That's why these questions are important. Now I have included that. This is my parent chain. Now the next question is, I can start numbering from here. 1, 2, 3, 4. Now in this case, what are the locants? So for COOH and for COOH, 1 and 4 is coming. If I number it like here also, this 1 and 4 will come. But here the substituent is having the locant 3. Now suppose if I do it in this way, the other way. 1, 2, 3, 4. Here we have an advantage. Again 1 and 4, but for the substituent, the locant coming here is 2. So this looks correct and this is wrong. Understood? So this is the correct way of numbering. Now the next case is naming it. Now tell me, parent chain has how many carbon atoms? 4 carbon atoms. So we use the word root but, and all are linked by single bond. So I will use butane. Then I know that at 1 and 4 you have carboxy. So 1, 4. Then both 2 are there. So I use the term dioic acid. That is completed. Now there is a 2 degree prefix is there. So I can say 2 hyphen hydroxy 2-hydroxy butane 1,4 dioic acid. This is the IUPAC name of malic acid. Understood? So please be careful while doing the naming. Okay, so we'll go to the next question. Okay, so in the next question, it's another very important acid that is called tartaric acid. In Malayalam we use the term puli. Okay, we used it in curries and all. Okay, that is called tartaric acid. Most commonly this will come in optical isomerism, so please remember its formula as well as the common name. Very, very important. Okay, so how will you name this compound? IUPAC name, tell me again. How many functional groups? COOH is a functional group. How many COOH are there? 2 are there. That is connected to the parent chain, correct? So if 2 is there, whether our special rule comes into play? No. So I can include this carbon in my parent carbon chain, correct? Now these 2 OH groups will behave like what? It will behave like a substituent. So here I can number it from any direction because anyway 2 OH groups are there, so it will not matter. So let me start from here. 1, 2, 3, 4. Okay. So tell me, what is the possible name of this compound? Can you tell? So I will start with the parent 4 carbon atoms. So my word root is but. All are connected through single bond. So I will say butane. Then 1 and 4. Butane 1,4 hyphen 2 are there. So dioic acid. Okay. Now is that complete? No, I didn't add the second degree prefix, so I should add that in second degree prefix 2 and 3. Correct, at 2 and 3 it is there, so I can write 2,3. Why? Because both are same actually. So 2,3 hyphen, then I could use di. Why? Because 2 are there. Dihydroxy. So you can see here 2,3 dihydroxy butane 1,4 dioic acid. Understood? That is called 2,3 dihydroxy butane 1,4 dioic acid is called tartaric acid. Okay, so please remember, I hope you understood how I have done this. Okay, why here 2,3 coming? Because both are OH groups similar, so that's why 2,3. So it should be separated by hyphen. Then why I am using di? Because both are similar. Di, then hydroxy, then parent chain but. All are connected through single bond AN. Then since it is oic acid, I removed the E. Then position 1,4. So separated from the alphabets by hyphen. Then I used dioic acid. That's it. So we'll go to the next example. Okay.